Hello, everybody. Still adjusting here a little bit. Doo-doo-doo. Nice. There we go. Get a slightly different vibe going for the off the record stream. Welcome, everybody. This one is the more unofficial. I'll do some explaining, especially after some more people are potentially going to show up. It's hard to know how this is coming through. If everybody could let me know how the quality seems to be. I gotta say right now, looking at YouTube, it doesn't look amazing. So give me a heads up. This stream is only on YouTube, which is, you can't do private streams in Twitch. So this is sort of a test to make sure it is still working on YouTube. I'm gonna do a internet speed test. Yeah, okay. Yeah, that seems fine. Hopefully the download is good, but hopefully the upload is good as well. Well, everybody's saying it's looking good. I gotta say for me, it's not looking so good. But hey, if it's working for you. Let me think. So as some people show up in YouTube, I imagine we'll have a slightly smaller crowd because YouTube is a little more difficult. But video is working. This is working. Stream is up. What is the idea here? Well, let me pull up the main screen here. Make sure I can still see the chat, though. Very important. The idea here is that, where's the correct window? New one. Do that. And then I will open up this. There's nothing for you to see quite yet. Nope. Aha. Cool. Okay. All right. Sorry, getting it all together. Boom. Okay. So, wait, is that? Oh, this is sharing the wrong screen. Hang on. I gotta tell the desktop to. How do I do that? Well, I'm just gonna turn that on for a moment. And tell this one that it's looking at the wrong screen. Display 2. Haha. Okay, not sure why I was on the wrong one. But there we go. Okay, so what is this stream? This stream is the bonus stream for people who are supporting on Patreon at the technician level or above. The idea is that I do my completely free, open live stream every Wednesday for 2 hours where I just take questions from everybody. It's really fun. I love doing it. It's really great. This is a bonus one where I essentially continue to try and focus on some sort of project or dive deeper onto some technique. The goal being is like I'm learning more about a specific part of cinema that I don't know as well, and then via chatting with the chat and via different ideas, eventually, hopefully, I learn a bunch of new stuff that will eventually make for a new awesome tutorial, or just so I can use it in other places, in different projects that we can show off. So I'll just put the link in here. If you're not already supporting on Patreon, this is the way to continue. But today I figured we would keep it completely open for everybody while we explore a pretty cool topic. I'm really excited. Yesterday during the live stream, somebody asked a question about, actually it was really cool. It's a still image from an art exhibit about wrinkly cloth. And we've kind of tackled this topic a bunch of times in the past. We've definitely attempted to do it, and this time it went really well. Like the wrinkles were really working awesomely, so I thought a good topic for today would be to try and go even deeper on that and essentially see if there's enough information here to try and make a full tutorial out of it. So we're going to keep on pushing it even further. Specifically, it could be really cool because we're going to be using fields and I think some field forces to try and get some more artistic control over exactly what's happening. So that should be very fun. Yeah, so I'm actually really looking forward to it. This is kind of a little bit of an experiment. This bonus stream has always been a bit of an experiment. It's a little bit more low key. I'm focused. I interact more directly with the chat as we're going. It's not like I usually in the normal episodes I sort of disappear. It's like, oh, here's a question, I disappear, I focus on that, and then go back to the chat because I don't want it to be all super interrupted all the time. Other quick things, just while we're talking about it, on the Patreon, if you're looking to support, which would be awesome, completely not necessary. One of my goals, one of the big goals is that I never, sorry, jumping back and forth, I don't want to ever lock information away behind a paywall. So this is more experimental. It's more for the people who want to get a little bit of extra thing. And if there's really great content that ends up coming from it, it'll get clipped out or turned into a full tutorial and be put out in the world. But if you like the kind of things that I do, then jumping on and supporting through Patreon is a great way to do it until we have some tools out there in the world. And once the tools are there, then buying those will be the best way to support. But in any case, on here, what ends up happening is you get access to the tutorials a little bit early. You'll get access to all of the live streams early. You get access to the bonus stream. And then you also get all of the scene files that I save will be there as well. With all the different levels. Some of them get crazy, but yeah, the engineer one, you get like every scene file. And I've been trying to keep up with that pretty well. So yep, that's all the information. With all of that in mind, let's see who we got. We got Tobias Muerto, or actually it's completely made up a new word for you. It's, what is it? Muerto? TKE Sports, hello, Emiliano, Jason, Harvard of course, Pete, how's it going? Let's see, how do you pronounce your name? Is it Dele? Could be a couple different ones, I'm not sure. Sean, Scott, Gregory, hi everybody, thanks for coming and hanging out. I'm excited. Taylor, hello. Hello from Mexico, from Emiliano. Very, very cool. D. Lee. Okay, D. Lee, thanks for coming, D. Lee. I'm excited. Jake from the UK. Yeah, where's everybody from in here? And I'm going to start getting the scene files up and ready to rock. So we'll review the old ones. And in the meantime, everybody do a shout out from where you're from. Hello from me from Chicago. Pretty, I don't have a camera angle where I can show you outside and the camera's all hooked up, but you know, I got the Willis Tower right outside. You can see everything in detail. It's pretty fun. I like it. I guess I'll open up this speedy one. Actually, get that open already. Cloth on the letter. Maybe we'll even build one from scratch just to learn. Let's see. Oregon, New York City. Very nice. Norway, Minneapolis, New Zealand, Sweden. Everybody's from everywhere. Awesome. New York City and Belgium. Excellent. New Zealand. Wow, look at this super amazing international audience. Very, very cool. Several people from New York representing. Very nice. I'm actually originally from New York, but we moved to Illinois when I was 8. So more New York. Crazy. So excellent. We got lots of people hanging out today. Once again, we'll do some recaps as we go throughout, but you know, normally this would be a Patreon only stream, but today, because it's the first episode of season 2, I'm just having it open for everybody. Libya, ooh, UK again. Excellent. All right, everybody, we are going to officially begin trying to learn some stuff. Boss Design, welcome. Abdo, welcome. Kent, hi, everybody. Kent's originally from Chicago and now in New York, so the opposite. Okay, so we're just beginning right now. Oh, Rocket Lasso New York City party. That'd be amazing. I had the opportunity, the timing ended up not working out, but I was almost in the New York. I was almost in New York for the 3D motion tour, but it ended up just, there's too much travel in one time. I had to get back and do some work, so I had to pass on that one. But in any case, I'm going to start focusing on the screen, but like I said, I do pay more attention to the chat. In fact, can I pop the chat out? Pop out. Excellent. And I can put this in the proper position. See that better. Minimize this so I can monitor to make sure we're still streaming. So yeah, I'll keep more of an eye on the chat in general, but here we are. Click on the screen, and here we are back in Cinema 4D R21, and this is what we're going to be tinkering with. If you weren't here in the stream yesterday, there was that question I mentioned, and this is a baked version, so it's running a lot quicker, but we get some cloth, and the very basic idea is we have the cloth grow. Let's see, I have the rest length keyframed, so it starts out originally at its 100%, and slowly over time it's scaling up to 200%. And because of all the friction on the object and on the ground, it's causing the cloth to just bunch up on itself because it doesn't have anywhere else to go. And I know this is the best, quickest, nicest wrinkles I've ever gotten in cinema, so I thought this could make for a really cool bigger tutorial. So let's tinker around. Let's see what the edges on this are. We got representing, we've also got France, Austria, London, And yes, wearing the cap today. It was also a way of distinguishing between the two episodes. You can have a different vibe. I don't like the background up in the air. I leave the camera a little bit more zoomed out. It's supposed to be a little bit more, rough on the edges. Okay, so you see the concept that we have here. I'm going to get rid of everything. I'm almost tempted to start from scratch again, just so we can. Actually, yeah, we'll do that. I'm going to kill off the old one, kill the cache, so the file is not very big. We got cloth. We were never using that. We've got the text, and let's tinker around. Just to. It's always good to start again from scratch to make sure that everything you think you know, you do actually know. I'm also going to unhide all these spheres. Another cool concept that we kind of accidentally, well, not accidentally, but it worked incredibly well, is I started putting little spheres on the. Oop, I'm going to get rid of the depth of field. I made a GIF, so I put the depth of field on. Anyway, I've got these spheres set to their dynamic spheres, collider bodies, and their shape is set to ellipsoid. And what that means is that they calculate very accurately, because if you have a polygon object, all it can do is look at each polygon and hope it doesn't pass through. But if it's a ellipsoid, then it's like, oh, I'm inside of that sphere. I shouldn't be, and it pops it back out in a more accurate way. And so by placing some of these on areas that we were having trouble, like it was passing through this side a lot, so I made a spline, and that spline, this spline, which spline? That spline? Well, it's not showing the points. Well, there's a spline that we ran along here and cloned a bunch of spheres, and we put a bunch there. Anywhere there's problem areas, and it doesn't really seem to slow us down too much, and there's a good way of adding extra detail for any points that were not cooperating. But in any case, let's create a plane. We'll put the velvet material on there again because it looks nice even in the viewport. Center this up on the letter. To tell you the truth, we should probably leave this zeroed out on Z and move everything else into position. So grab everything, scoot that over here. So the plane is at 0. Just seems a little more accurate. So what there's a lot of little tests I would like to do, but let's go step by step. So everything's a collider body, that's fine. But we're going to start from scratch on this plane. If I NB, of course we can see our polygons. Very, very low polygon. Not much is going to happen, but it's a fine place to start. Simulation, soft body. A lot of things we can do for testing purposes. Actually, one that might be really useful. That looks like we got some Russian typed in there, so I'm going to assume that's Russian. I'm not entirely sure. Vienna, Austria, excellent. Anyway, back to here. So not very many polygons. It's going to run really quick. In fact, we can definitely double, or I'm going to go up to 25. It should still run pretty quick for us. And actually, let's just find out. I'm going to hit play, falls, and you see it's running 14 frames a second, between 14 and 20 frames a second. Not too bad. Very, very fast. Now, something I want to point out, speed-wise, is right now, like I said, it's depending on how many collisions are happening, it's dropping down to around 20. But something that's kind of fun is we can turn off self-collisions, and that should... Well, it's actually not... I thought that'd speed us up more. But it's not speeding up that much. I've never... Yeah, interesting. That could make a difference later. I thought it'd make more of a difference right now. We'll keep that in mind. For testing purposes, it could be good to turn that off if it does make things go faster. There's also use accurate solver. I'm reluctant to turn it off, but it does run a different algorithm when you're running your dynamics, so that could be useful to know as well. So this is going to fall down. It strikes the surface, and it's going to immediately start tapering down. So I'd say there's no, yeah, let's go to 15 frames in. Scale of 100. Now, one of the goals here is we could have it be bigger, shrink down, and then get bigger again. But that means you need to pre-roll a bunch of frames. So I think it's hopefully self-evident. Well, I hope it's self-evident. I hope the assumption of it being self-evident is accurate. There we go. And then we want to give it some time to grow. Well, actually, even here's the thing. I guess it would naturally do it, but if we go a single frame forward and suddenly jump it to its final scale of 200, drag that back. So now there's only a single frame in which it's changing. You can get some explosions. It can really, did I not? Okay, I just completely and utterly misclicked everything there. So at the time of 16, scale 200%, record. There. Sorry about that. So it should play, and then once we hit that frame, it's suddenly going to explode outward. And depending on your dynamic settings, there'll suddenly be a bunch of self-collisions. There'll suddenly be kind of a burst outward of all this energy. So typically, I think it's a good idea to transition that slowly over time. So that would be giving it 15 frames. Let's give it quite a few. Here, that's about, what is that, about 20 frames? Sorry, the timeline scale that way is really throwing me off. So yeah, we're going to 10, 20, 30 frames for it to do that transition now. So you see it's going to fall and then more slowly grow, and it slides into that new position. Now at the smaller resolution, obviously it's not changing all that much. So without the resolution, we got to make a lot of changes. Now, something we were definitely chatting about was that the structural, shear, and flexion, of course, are stylistically going to change the way this works. But depending on your point count, your polygons, is going to dramatically change the way these work as well. So I feel like finding the resolution of your polygons here is one of the more important factors to get early on, because that will literally change every setting that comes after it as well. So this begins growing. I don't see any reason for these not to be linear. So I'm going to select both and say linear keyframes so it doesn't slowly transition. Might be a little bit of a pop there, but let's just keep it going. And now you just see I essentially doubled our resolution, and already you can see we're getting a lot more in the way of wrinkles here. In fact, they bunched up pretty interestingly here in the center point. That might be that little extra speed burst, but I just want to take another look at it and see what it does. So they start growing, the various frictions and places it doesn't know where to go. Especially these start falling down the pit, so those can't slide anymore because they fell down, and they fell down here. So the stuff in the middle doesn't have anywhere to go except for it to grow and flop over itself. Now, obviously, you're not going to be able to get a great animated ring. I mean, obviously, the cloth here is magically growing, but the alternative, I think, would be to, I guess you'd have to compress the cloth and drop it in a compressed way, which could be something else to pursue. Although at this relatively low resolution, I gotta say I'm pretty happy with these nice little overlaps. We take our plane, put it inside a subdivision surface, and change our display mode, and there we go. Pretty nice looking overall. We got a couple nice big wrinkles. Quite pleased with that. Now, something I don't think we ended up testing yesterday, which I'd really like to test, is let's try making this editable and triangulating it. Now, I wish there's a good way to randomly orient. There used to be one I remembered. I'm not sure. But in any case, I'm just going to make this editable. And I'm going to right-click on everything, and there is a triangulate. There's not even a shortcut for it, and I don't do it very often, so I don't think it's one that needs to be memorized. So you see we got triangles now, which means these can bend more easily on that angle, which could introduce some good additional detail in the way they bend, but every single one of those triangles is traveling the same direction. I just want to see what this does to start out. This is still running relatively quickly. Oh, interesting. Interesting. I'm going to pause that right away because I didn't change. All I did was make this editable and triangulate it, and suddenly it is taking significantly longer. Now, technically, we did double the polygon count because every polygon got cut in half. But that is running way slower. So that is a surprise. I'm going to undo, actually. And let's drop this poly count back down to about half the amount, make that editable, and triangulate this. And I want to see if it feels like we're about at that same speed, or is there something extra slow about triangles. Hit play. Oh, most interesting. Look at that. We seem to be getting... Okay, a lot of interesting information here. Give me a second, I got some dust on the screen, and the sun is coming through in such a way where it's kind of blinding me. Okay, something very interesting is happening. We've got all these triangles, and clearly these are able to stretch on that orientation more. You can feel a very distinct stretching in the angle of the triangulation. In addition to that, we've got all this extra resolution, but like we've lost a lot of detail in the shape that we had been getting. So this triangulation method might not be as cracked up to be as we were hoping it would. Now, something I want to test is if we can rotate our edges And there is a function for rotating an edge, spin edge. Let's see, click. Okay, so you can see I had this one point selected and I spun the edge, and spinning the edge allows it to go to a different orientation. Now what I'd like to do is have, essentially randomly select it. I think that's gonna be pretty tough, to tell you the truth. Shrink, nope, that doesn't work. Like without manually going through, I mean, we could do something like this, but I'm pretty sure if I try and spin this edge, it's not going to do anything. We have to very carefully grab these middle triangles, and we can randomly, and let's see if we even do that, spin edge. Okay, those spin. Now you can see that those have been oriented the other direction. And the idea would be is like, oh, by modifying the mesh in that kind of way, we can start getting some more randomized motion where it's kind of like there's some variation built right into them. But that's going to be such a manual process that I just feel like it starts getting not practical. So instead, we're just going to undo a bunch, get back to our polygon object. And in spite of these not being triangles, they do just a single polygon has the option of bending in more ways, because you can imagine this as a triangle in both directions, but very clearly, very quickly in dynamics, you'll see that it can bend like this. So you get this funky shape like that. But essentially, this is like a triangle, but it might also bend like that, which gives us the other triangle. So it kind of gives us both of those for free. So actually doing these rectangles might be the superior method. Now, even having said that, there are additional types of subdivision that could lead, if we were seeing something very polygonal, there's other types of configuration that might give us more interesting looking layouts. One that jumps to mind, I'm gonna make that editable again. I'm gonna create, actually we can do it not parametrically. I'm gonna do bevel, MS being the shortcut for bevel. If you set your bevel to, yeah, we're on point mode here. So if I limit it, then we can do a big, I'm trying to do it very slowly. You can see I can pull this out and you get a inverse of it. So you can see all of our squares have gone to the opposite direction. Now there's actually a bunch of overlapping points here by beveling every point. If I were to pull this up, you're gonna see that there's actually, well, I'm not sure where they live. Unless it welded them, that would be weird. But in any case, I don't trust these points. So I'm gonna optimize, select all, optimize UO being the shortcut. So those should be all welded together. And now, I don't know if that changes our resolution, like the number of polygons, but that does change our orientation of them. So it's kind of a cool additional option. I don't really expect it to behave fundamentally differently, but it's nice that it is there at all. So there is that. Now, if of course you put that into a subdivision surface, it's just going to give you, let's drop that to 1. It just subdivides more in the same way. So that doesn't do anything particularly intriguing, but let me think. Is saying I would do great in Houdini. It's the way I think. I agree, but I don't know. It's just not. I think it would be really fun, and I have tinkered in it, but I just don't. I love the world of cinema. I love the community in cinema, and then there's just not like when you try and go as deep into it as I do. At least for me, it takes so much time that I wouldn't be comfortable trying to teach something that I don't feel kind of like really having been able to go in depth and explain why things are happening. So Houdini just turns into a weird hole to go down. I'm not closing myself off totally to the idea, but you know, I know Cinema 4D. I know the people in the world of Cinema 4D. I love the tool. It's easy to use. And I just feel like the tools I want to make are better for the Cinema 4D audience. So that I'm not looking to go anywhere right now. But I do think I would really enjoy using Houdini. I get told that a lot by people. Now I'm trying to remember, what am I doing wrong here? Oh, I think I remember the configuration. I'm just trying to introduce like some different point counts or different ways of distributing points. And here's another fun one. If I select, well, if we need this to be very precise, I think. These are exactly 16 wide. So if I select everything and we do another bevel, MS, and I'm going to do a Oh, we're in polygon mode, so we're, oh, and I need to turn off preserve groups. Then now we're going to be beveling every single one of these. Now, if limit is turned on, does it do it automatically for us? Pull it down. Nope. Okay, be careful. Bevel offset. I don't want any offset. That should be 0. Polygon extrusion. That should be 0. Now I'm going to pull. Yeah, this one's just being a little bit of a pain, so we'll do it manually. Don't extrude, please. Oh. Okay, yeah, well, I thought it would be trouble. So we need to type in our number automatically. So I'm going to type in 16. Now, I think we actually need half. Okay, it is limiting. So we just need to go into positive here. Typing the numbers was easier. Because limit is turned on, it will clamp it accurately. But the point being here is by doing a polygon extrusion, turning off preserve groups, it has now extruded all of these into the center point. And now you see that we do get these triangulated shapes. Now, we have made 4 times as many points, and they're triangles, and we need to select all the points and optimize again. So select all UO to optimize. But we have now introduced double the angles for it to go to. So I think this is a pretty good shape. Let's see, Shane. I don't know about the X particles cloth. I'm not an expert in it. I should tinker in it more. I'm not sure how good it would do on Wrinkles. And Philip, I have not played with this anymore since yesterday. So this is just, continuing to explore. So this is with a bunch more, but we got all these additional angles. I'm just curious. I mean, it's a little difficult to know for sure if this is more resolution. Like, is this bending more? Because if we have 4 times as many polygons, of course there would be more resolution. But does creating these kind of angles allow for more bends? I'm just not sure. And that's kind of what we're here to explore. Now, what I would like to do is go easy on our shear. I'm going to pull back on the shear. I'm going to put the damping down to 1. Let's just see if that does anything, because damping always does a surprising amount. So as this grows, just by pulling damping down, does anything fundamentally change? Seemingly no. It seems quite structural still. And that drains the energy out, so that actually could be quite important. I hadn't thought about that. We might want high damping on things. Something to keep in mind. Actually, yeah, let's do that. I'm going to crank our damping up instead of down, which is not something I normally do. But in this instance, I'll explain when we get there. Already you can see high damping is making it so that was conforming to the shape a little bit more. What damping is doing is it's draining tons of energy out from those individual systems. Wow. Okay. We just learned something really important. Typically, we put those lower as numbers so we don't drain the energy out. But by draining a lot more energy, I'm going to increase my timeline. By draining more energy out from those systems, you can see how it's forcing it to fall. Look how slowly these parts are falling down and smoothly getting into new positions. This has so much more of the form of our shape than we had a second ago. And all we did was change the damping. You would always think that damping is like a tiny parameter, but I've always found it to be more important than the base parameter that's modifying. Very, very interesting. Look at that. Look at that. Okay, we just learned some good information. Now, with that information, I wish I hadn't. Yeah, I'm going to copy that. So we get that object and hit undo a bunch of times until we're back to a parametric plane. There we go. Paste in the one we were just playing with. Now, unfortunately, we can't stop that from running, but I can pull the dynamics tag off, and that will stop it from running. Now, what I'd like to do is let's see how many polygons this has. I'm going to select all, and poly count. Selected polys, 2,500. Now, this one, I'm going to make this editable, and this is only 625. I'm just going to guess, and I want to get that to the same amount, and let's see which one gives us better resolution. Oh, okay, like 50 by 50 gave us exactly the amount, so that was a very accurate first guess. In fact, I'm going to delete its selection tag, its dynamics tag off, and we'll just steal the previous one. So these now have exactly the same poly count, but one is a triangle version, and the other is a quad version. And let's see what it gives us. Growing. Okay, well, it's definitely conforming to the shape more accurately, indeed. We're getting about 3 frames a second, so let's do a time test as well. I gotta say, we're getting more nice folds here. They can pinch more accurately when they're all lined up. You see very distinctly, stylistically, a big difference in those. Taking a while for parts to actually flow down, but we are definitely getting a lot more of the shape emerged. I'm not sure I'm fully understanding it. We're getting a little twitchy on a couple of these polygons. We always put a couple spheres there to make it work better. And we could do more substeps, addressing what ArtPunk is mentioning. More substeps in the project would go a long way. I try to not do that unless I absolutely need to, because it's kind of brute force. It completely changes your simulation, slows everything down. So if we have alternatives, I will do that. Very quickly, I will go to that if the circumstance is correct. But you saw that that was running about 3 frames a second once it started colliding quite a bit. And we stylistically are getting a lot of detail, but we get nice looking folds. So with that in mind, let's rewind. Always make changes at 0 when playing with dynamics. Switch the dynamics tag back to the same poly count, but completely different shape of this mesh. And let's see what our playback is on here. You can't trust the first few frames because it's not colliding with anything. Immediately, it is dropping to the same frame count, so the triangles don't seem to make a difference. In fact, this seems to run even perhaps a little bit faster. It's literally the same settings. It's got more of the form, but you can see that, I don't know, we're not getting the same pinching effect. It feels more flowy instead of folding, which is an interesting detail. It's definitely fighting back a little bit in various places. Pretty interesting. Stylistically, I feel like the quads were giving us more in the way of wrinkles, but it's nice to know that this mesh is the same speed, the triangles are the same speed. Doing those kind of A/B tests is what's going to give us all of the information. So now we're back to this mesh, and we can start zeroing in on some other settings. Now, I was about to do something, I can't remember what it was. What was I about to do? So these are all falling. The gravity. What's interesting to me is we put all this damping in the flexion, but you can see how these really don't want to bend. I guess maybe that makes sense. It's draining the energy out so that the springs don't have a lot of follow through. If they have a lot of follow through, they'll immediately start tapering downward. And if they immediately start kind of all cascading downward, then there's less weight pulling down. You get less of a defined shape is what I'm thinking. Logan, how far do you have to push that on? I mean, this isn't that high of a poly count. This is a very good machine. If I tried to run this on a laptop, it certainly wouldn't be great. But this is 2,500 polygons. A lot, but not insane. And for the most part, this could be an animation technique, perhaps, but this is more currently about getting just a nice mesh going. But in any case, the high flexion is doing a great job of this slowly wafting down. As it grows, a lot of these don't have anywhere to go. So even before it's a ground, you can see it's starting to wrinkle and crumple up because there's nowhere for it to go. Pretty interesting. Now, very happy with those experiments. Let's lower the direct shear and flexion to 1/10 of the amount, and that should just enable it to bend more. So my assumption would be that we're going to get a sharper shape going, but I'm really curious. Yeah, we get a very defined shape. It's all going to grow, but a lot of energy is still being drained out. Oh, immediately, even with our low poly count, look at all these wrinkles that are being, like smaller wrinkles that are being introduced. So far, kind of given the same poly count, this is by far given us the most draping and everything just slowly overlapping. I think that one looks great for how low polygon we are. Throw that in here, hit A rather, and look at these nice wrinkles. That's gorgeous. It still would need a few frames for some of these to settle down, but that is great. Look at that. I really like that. So what do we do here? I mean, really, a lot of this just turns into like exploring. If there's something cool or weird that you would like to see, feel free to shout out in the chat about something specific on this topic of cloth. I'm trying to focus on the areas that I have some expertise, which is why we're using soft bodies and not even though I do have X particles with the cloth simulation. I would love to tinker with that, but right now to introduce these wrinkles. I'm trying to do it in vanilla cinema. But the next thing I would like to do is try and art direct these a little bit. And to do that, I'm thinking field forces is the obvious way to go to start pulling some things around. So why don't we start going? We've got this relatively low poly. We got this nice growth going. In fact, we should probably save the scene file. We've got our new rocket. We're off the record. Season 2, episode 1. Scene file. 1A. Cloth wrinkle tests. Okay. So here's where things can get fun, is making different areas get affected by different forces and using field forces. Now, what I'm trying to think of right now is, how do we want to tug on a particular spot? I'm kind of thinking a cylinder shape might be a good way to go. So here's the plan. I'm going to make a field force. So we find that under simulate forces, field force. Now what this is going to do is field forces is automatically, it's going to take as long to calculate as you have points, because each point is looking into the field force, and the more complex the field force, the more calculations each individual point has to take. Now the thought here is, if we were to create something like I'm going to start out with just a capsule shape. So it's going to be a long cylindrical tube. I'm going to make it very tall, so it's like almost infinitely tall there. And then the radius, yeah, it's a little bit strange the way it displays it like that. It looks like a flat shape, but it's actually a cylinder. So I'm going to make a relatively thin cylinder right there. In fact, I'm going to have a full range of remapping. So it's fading from the center out to the edge. And that's where the effect is going to happen. So we're inside of the field force. Actually, got to be careful. You see, I'm actually in the fall off right now. And that could be fine. The fall off could be what I want to do. In fact, you know what? Actually, that is fine. That is where it's going to be affected. But what do I want to do? Well, right here is where we have to do that. And I'm going to say that I want to have it just push upward. It's going to be like a wind blowing things upwards. I'm going to create a solid. And currently it's set to X, Y, Z, Y positive. So that means everything should be blowing upward in the air. Currently it's set to velocity, which means it should be constantly adding a force in. And things should only be affected if it's in that cylinder. So let's see if this works at all. I'm going to hit play. And immediately we should hopefully get to see some sort of effect. Hitting play. I gotta say I'm not really seeing much of an effect. We're going to go pretty extreme on the settings here. So that's very strong on the cylindrical force. I'm going to increase that quite a bit. And now you can see that you can see this little preview that we have, which is nice. It's actually a grid of preview. I've talked about this before, and we're not going to go super deep into it right now. But in our field force, I'm going to go to display. We've got X, Y, Z. I'm going to put Y down to 0, so it becomes a two-dimensional box, and the position of it doesn't technically matter. So I'm just going to move up here in the air, right where our plane starts. And you can see this is where the forces should be getting applied. So with any luck, we should see, yeah, it's going to get pulled upward. You can even see it's getting pulled upward based on that fall off. So it is working. Now, we're in that cylinder, so even as it pulls up in the air, it's still getting the same amount of power, which is why I made it a cylinder and not a sphere. Cool. So pretty good strength. Shrink this quite a bit. I only want a small part in the center being affected. And now, indeed, you can see that there is a little bit. So we just have to increase the power a lot. Now, I think we're going to have to increase that power significantly even more. Although you can see it is pulling on it. It's giving that a nice tug. I'm going to turn off subdivision surface. I just want to see our actual points and B so we can see these. So you can see these getting pulled up. Now, one thing you'll notice is in our dynamics in the soft body, I didn't change the structural, so that is making it so these can't stretch very much. They're always going to be interlocked to the other ones very accurately. So you can see that this is actually working quite nicely. So pretty much exactly what I want. As the forces settle, it is able to start tugging on that a little bit. You gotta keep in mind that we are running very slowly, so this is actually going this should be going 10 times as fast if we were playing in real time. So this is successfully pulling up on that. What's interesting is as a point gets pulled more towards that point, it should get into that fall off and thus get pulled up more. Now, at a certain point, it did stop pulling. So let's increase that power some more. I'm going to go 3 times as strong, putting a 1 in front of that. So now it's going to go back to tugging this into the air. Not bad. Now what I'd love to do is be able to pull this up and drape it a little bit and then drop it and then see it kind of fall over on itself. So the weakness of this is going down a little bit more again. I'm going to go 5 times as strong as we currently are. This should pretty heavily start pulling things up into the air. A little too much so. We might need to ramp into it. I'm just going to go to double that amount. But I think once it lies flat on the ground... Oh, interesting. This is probably the damping. All that damping is pulling it down. Or we might be running into that soft body average position issue, which you never know. Could be. And if that's the case, I can't get into that. My brain still barely even comprehends it. I'm going to temporarily tell this to follow position, follow rotation, and I want to see if the effect is any different. And that will tell me which problem we're seeing. If this gets sucked up into the air, yeah, it was that issue. Interesting. All right. I'm going to leave the follow position, follow rotation, because what was happening is that there's like a bounding box that gets moved with the dynamics based on the average position of all of the points, and thus other points start getting pulled through the air when that happens. That might have something to do with like keep soft body shape. I think there might be a setting that does it. In fact, I would love to find out. So I'm going to zero those back out again and turn off keep soft body shape, and let's see if it still pulls all of it up in the air. It does, so that's not it. I don't think use deformed object is going to have any effect, but yeah, no, use deformed object is a very specific thing. Keep soft body shape has no effect. Accurate solver, we've played with that, but we don't want to. Yeah, we don't want to mess with it. So yeah, it just goes back to the overall bounding box. As I've only ever found, it was during off the record, and we found 2 different ways of dealing with that issue. One is to actually do this position follow thing, like locking it into position like that. And the other is tricking it into having a much, much, much bigger mesh, bigger bounding box, and then those outer ones aren't affected. I don't want to do that right now, and since the follow position seems to be working well enough, I'm going to allow that to happen. Pretty much what I want to have happen is this do that kind of thing, which is just stretching everything a lot. Although I'm going to increase our structure. Damping drains the energy out. I want to see if I just drop that down to 1. Not really visually seeing much of a difference. And now we'll jump it to 99. See what that does. I'm not really distinctly seeing a difference one way or another on structural. So I think straight up, I'm going to leave that default damping, and just the straight up structural is the important one. I'm going to double the power of that. I really don't want these to stretch. So as these polygons go up, I want it to be because these other ones are getting pulled inside. And the goal of that, the reason for that is right here on the same frame that everything else was going. I want to turn off our field force. And actually, I will do it the way I just described it. I'm going to turn it off. That way we can change the value still. So I'm going to keyframe that, hit the letter G to go 1 frame forward, turn it off, and now those are entirely off. And if we continue simulation, those will cease to be pulled up, and now they can just fall. And I want to see how they kind of crumple in on themselves. Okay, it's surprisingly structural. Quite surprising. I mean, it is falling, and I think given more time, it will fall entirely, but I'm kind of surprised at how very, very structural that is. I'm going to go back and really kill off the shear and the damping and see if that has any additional effect. Nice reference, Zach. I approve. And then suddenly it, boom, turns off, and it starts falling. Now we do know that the damping, the damping here is draining the energy a lot. Flavio, or is it Flavio? Flavio is asking, follow position is maintaining its position. What's the best way to explain it? I do have an understanding of it, but it's such a mathematical, technical limitation that it starts getting difficult to describe. Imagine that this is a soft body, and if there's a wind, well, let's grab some of the points. You know, it's pretty much what we're doing with the cloth. Like as a cloth gets pulled up from the center point, I guess we can just literally stay in that scene file because it is visually doing it. So as these points get pulled upward, imagine there's a bounding box being drawn around here. Like imagine you had to trap this in a box. The center point of that box is traveling upward. And once it travels upward a certain amount, then there's something in dynamics where it's like, oh, the center point is moving, so the object should move up with that center point. Now, by turning on follow position and follow rotation, we're saying, no, that center point shouldn't move. Stay where it is. And hopefully it's just the individual points that are moving and not the overall object. Having said that, that might stop some of the stuff from flopping over and whatnot. In fact, we should do that. I'm going to turn off our field. Oh, I can't turn it off because that's keyframed. So we have to, I'm just going to zero it out for a second. So, oh yeah, we got to be careful. Yeah. See, now it's not falling. Yeah. I'd say we got to be really, really careful because now, by turning on follow position, gravity's not allowing it to fall. And you would think that the individual points could move, but no, it's the combination of those two things I was saying, which is very frustrating. And that puts us back into the position of having to do the overly complex fix for this. I don't think we have to go too crazy because all these are very well contained. But here's the basic idea. I'm going to make a single polygon, 55, 55. And so you can see, boom, I got this polygon. I'm going to put that polygon into a cloner. And that cloner I'm going to set to grid array. And that will be set to 2 by 2 by 2. So what this is all translating to is we now have 2 by 2 by 2. We now have essentially a square. We have a polygon on the corner of what would be each corner of the cube. All right. So that becomes our volume. This is where everything can be contained. Now I do have to be careful. I'm going to set this to exactly 800 tall because we need to move this 400 into the air because some of those will be touching the ground. In fact, I'm going to move it 401 into the air. So you can see that we've got that, each with a single polygon. If we take these polygon helpers, I'm going to make a connect, put this into the connect, and I'm also going to put our very nice cloth into the connect. So now all of that is one mesh, and we move our dynamics tag. I guess I should put the right object in there. It's actually this one. Now all of that's getting connected into a single model, and as I move that up, then those are also dynamic and technically still part of the same object. But now there's a bigger bounding box. With that in mind, I'm going to, oh man, I hate that we have to go this complicated, but this is why we're playing with it. If we have to turn off gravity. So I have to hit Control or Command D, go to Dynamics, go to General, and turn gravity down to 0. Because otherwise, everything is going to have gravity and it's all going to fall down. Instead, what we're going to do is say, hey, there's no gravity here, which means if I play, essentially nothing should happen. They're going to grow. Oh, okay. And actually, look, these grow, but they shouldn't move unless they do. I don't know if they will or not. But yeah, I kind of forgot that those are going to grow. And I guess these are bouncing off the ground, so they start moving. Probably a good idea to add some sort of friction on those. We'll deal with that when we get there. But there's no gravity anymore, so those aren't moving. So now we essentially need to make an artificial gravity. We need some alternative of gravity. So I'll keep the simple version of this. I'm just going to make a wind, and the wind always blows on Z. So Z will blow downward, -90. And this wind blowing downward, I don't want it to go everywhere. I want it to only go inside of this box. So here's a box. And I'm going to say that the box is at full power all the time. So anywhere any of this pink is, it's at full power. So I can make this box as large as I want, as long as I don't get so large that it intersects with our little helpers on the outside. So now there's a gravity in there that's not affecting these outer ones. Now, I don't remember exactly what we need this to be gravity. I'm going to say 1,000. I'm thinking that's probably too strong. Hit play. Yeah, you see it's getting blasted downward very quickly. So let's try, is it 100? That feels a little bit more accurate. Now, I think I still have follow position on. So with those off now, even as these points move, they're all still trapped within our pseudo bounding box. Thus, the midpoint of our axis won't change, thus meaning that this should be able to behave a little bit better. That's the hope. I think our gravity is still way too strong. Now, as these scale, they do seem to want to float up into the air. We could create a friction. I'm not 100% sure, but I think I found that using friction, which is amazing, but using friction with a fall off can be very strange. I'm going to copy this box, put it into the friction, say the friction's fall off should be based off the box, but in the box itself, I'm going to say to invert it. So it's literally the opposite. There should be no friction inside the box, but there is friction outside of the box. You know what? I shouldn't do that. That box is really handy like the way it is. So in this friction, I'm going to feed it the very same box that the wind has. And if I change this, they both change, but I can add an invert on top of this. So just the friction is looking at the box, but inverting what should be affected. So now we've got a very, very strong friction that exists outside of this fall off, and hopefully these will be a lot less inclined to drift. They will grow, but hopefully they won't drift too far away. Seemingly so. These are intersecting the ground a little bit. Oop, it's getting real upset about something there. I'm gonna try and pause it. I clicked pause once. Cinema should acknowledge it, but it's going to take a while there. Okay. Yeah, I don't like what it just did there. I'm going to scoot the polygon helpers up into the air a little bit more. Of course, I do think those kind of become the ground level, so moving those up 10, I'm hoping that gives less of a chance of them intersecting the ground and freaking out, but we're getting into danger territory here. But you saw that escaped through the ground, and that's bad. I think that's why it flipped out. Yeah, this little extra space seems to be enough to keep them above ground. It's also a floor, so like the instant that one went below ground, it didn't like it. What's throwing me off is the ground is like a very mathematically accurate thing. Things shouldn't be able to get below that floor. So the fact that they are is worrying. And there's also the issue that we don't want this to fall through the ground. I do really like using the ground because it's super duper accurate, but because these are passing through it, I'm feeling like we might have to make a plane. So this is the ground. I really don't want to do that, but if it's going to force me to, then we'll do it. So sorry, floor, you're not actually doing anything. I guess just to be clear, we will delete it. And now those can't pass through the floor because there is no floor to pass through. So these are able to now travel downward to do their thing. Those can hopefully grow to their full potential without causing us any trouble. They grow quite large. Oh, they're still exploding. Who would have thought that a couple of rogue polygons in the corners were going to give us so much trouble? Yeah, look at this. We're immediately going off the rails. I really wish there was some sort of checkbox here or something, because this starts getting so unintuitive. Like, I mean, if I'm gonna make a tutorial of this, we can't be doing stuff like making this box here. It's so weird. So I'll keep it here, but we're gonna ignore it. So yeah, we're back to more basics here. And yeah, I want to let's you know what? Let's undo, get that back again. Save this, just cause. And I'm immediately going to save again into a new one so we can kill off wind, friction, get rid of the helpers. We can always go back and pull them back in again if we want to. All right, so there we go. We're back. And we're back. Okay. Oh, and gravity is still turned off, so reset that back to 0. Control D. Excuse me. Oh dang! I deleted the dynamics tag. Steal the dynamics tag. The material. Now delete that. Now turn gravity back on. Apparently gravity doesn't have to do in the undo sequence. All right, now we're back to where we were. Now let's see. I don't want to fight the follow position. If we have follow position on, you see those don't fall down properly. So now those are not there, so these should fall down properly. There is no follow position. That's fine. Although, look at what changed here. Did we change something? I was playing a bunch with checkboxes, but why do these wrinkles look so different? Or were we playing with our fun shape before? But I mean, what did we just change? Because look at these. Look how everything's becoming so perfectly uniformly wrinkled. I feel like before we were getting such a nice overlap. What did I not revert to? Or was that just the follow position was doing that? Curious. Give it a shot. Yeah, that doesn't make sense because it wouldn't float down at all. We did increase the structure. We're gonna hit undo a lot of times. Come on, undos. It's doing a good job. Okay, there's where we... Okay, I'm out of undos, but now it's right when we were starting to create those outer bits. Let's see what happens. What do we got? Gravity, yes. We're back to... Now, actually, this is what's throwing me off, is when we turned on follow position, everything was still falling, wasn't it? Or we didn't turn that on until we started drifting that upward. I'm not sure. Let's open up our A file. See where we were at on this one. Okay, they are falling. Now, okay, interesting. So that's falling. There's no follow position, no follow rotation. It is growing, and we're getting sexy looking wrinkles. All right. Now, what changed? If we put the follow on, I'm going to assume if we put this follow on, it's just going to float in the air and get all wrinkly there. But even that, like, look, these are nicer wrinkles. These are, like, those are a lot less patterned. And this is the rectangles, not the triangle version. Now we want them to fall. I mean, I guess we changed the structural. If that's the only change, I'm going to be disappointed. Was it the structural? These do seem a lot more bunchy. I don't know, but we'll just continue from here. Although, I do want to say that structural probably has a lot more to do with these wrinkles than I was originally thinking. Because if they're not allowed to stretch at all, then they really don't have anywhere to go, and we're going to get more bunching up. I think we're getting one small explosion there, but these are really, really going to get very bunchy, which is nice. And I'm thinking if we have very low structure, drop that down to 10, my guess would be that we get significantly less. Yeah, no, we're fully scaling right now, and as we scale, we're getting almost no wrinkles. So yeah, structural has a lot to do with the wrinkles, because if they're allowed to stretch, a lot, then yeah, you can get big polygon, small ones, and there's no need for a wrinkle. But when they're not allowed to stretch, then interesting things happen. All right. Well, with that in mind, let's see when there's almost no damping. So there's no energy drained out. A lot of wrinkles. Yeah, they're pinching all over the place. I do feel like there's a couple of slight explodey bits, but maybe not. Very much fighting, very much bunching up on top of each other. Pretty good looking overall. Now let's do 99% damping, draining tons of the energy out. Let's see. Seems to more quickly take on the contour of the overall shape. There's still a lot of wrinkles all over the place. Less bunched up. But I gotta say, not terribly different overall. I feel like it took on the shape a lot. Lot of energy being pulled out, taking on the shape very well. Lots of big wrinkles. Actually, they're not exploding. They just don't have anywhere to go, so they're kind of blasting up on top of each other. But very nice overall. I like those. All of that's fine. No complaints with that. It makes sense. And now we're back to a 200%. I'm going to save this as ABCD1D. And let's pull our very nice field force back into the scene. All right, so we got our field force back. It should instantly be affecting it. Now, let's see if we are going to have to combat that same problem. I'm just super curious. So now there should be a force which is pulling this up into the air. Interestingly, it didn't do anything off the bat, even though this should automatically have all forces applied. I'm going to rewind, hit play again. Oh, wait, it shouldn't be having effect because I zeroed it out, and this should be up to 255. 5. Okay, there, now there's enough for it to pull up. But now, as this gets pulled up, are we going to start getting that bounding box issue? Like I said, yeah, see, nothing changed except I had this field force, and suddenly these don't want to fall down to the ground. Everything's getting pulled into the air via that center point. Now, right here, it should suddenly turn off, and now everything is going to start falling. Very strange. That is not very useful behavior. But let's just see what happens. I want to see how the wrinkles fall. We'll actually let it go a little bit further. Because you see there's a lot of structure here. But we said that we gave it a lot, the very low shear, very low flexion, which gives it a lot of, it can bend and crumple in a lot of ways. And with very little, there's a lot of structure, which means it can't stretch. So that means it has to fold in on itself. And you can see it is folding, but there's enough structure where it's kind of, it's maintaining some almost like structural integrity. So what I'm going to do is double our gravity. Let's say there's twice as much gravity here. I might do something a little bit different. There's several ways I can think of doing this. Now this is going to have twice as much gravity, so this might get pulled up half as much. It's still getting pulled up quite well. The extra gravity is doing a nice job of countering this pulling up, and this is still falling. That turns off. I don't think it's stretched quite as much, but let's see if the extra gravity is enough to let that fall more. Essentially, that's just us bunching up a bunch of the cloth, so it needs somewhere to go. And yeah, you can see it's definitely, the double gravity is collapsing this a lot better. This is really getting pulled down. And let's see, even something right here, you can see that it's like, okay, beautiful extra overlapping here. And this is where, as Flavio was saying, that soft body would be better than the cloth sim. I said, yeah, we have a cloth sim system, but it does not handle intersecting polygons very well, and this is stopping things from intersecting. It's actually doing a brilliant job of it. So yeah, look, we get this nice extra clump folded up in there. Nice little bit of extra art direction just for that little bit. So, okay, so that's a useful detail. This is still working well. We can work around those limitations. We're still getting some of these little parts peeking through. We could crank up our sets per frame. It's not bothering me right now. Is potentially something to deal with a little bit later. Okay, so that worked great. I'm pleased with that. The extra gravity worked nicely. The alternative I was going to do was going to be to invert the strength. So it's going to go from very powerful one direction to very powerful the opposite direction. So it's pull it up and then pull it down. Now, just for fun, let's do this in 2 different spots. Very simple to do. I'm going to create a second cylindrical field. Pull this off to this corner. And let's have the fall off. I'm going to add the second one in. And I think they're both set to normal, so I think they would both run, but I'm just going to say add just to make sure that they are both there. Excellent. So I think right away we'll see double things go up, which is accurate, but I actually don't want this one to start right away. I'm going to say that it shouldn't start until the other one's kind of done. So we'll enable it here. Actually, I'll disable it here. 1 frame forward, enable, and then after 30 frames, it is enabled, and 1 more frame later, it's disabled. And let's just let it go. I can't believe an hour and 10 minutes have already gone by. It's crazy. All right, that's working nicely. The double gravity does counter that, although I still don't like that idea. Conceptually, it's worrying. Using the field forces here is cool, but there's a couple different types of forces. First of all, we could just bash another piece of geometry through there. We could also potentially use a spring. No, that's weird. Did our field force not kick on? Enable. Oh, the field force turns off. Whoopsie. That's my bad. Okay, so currently the field force was turning itself on and off. I want that to always be on, and we'll just turn on and off this fall off. So at this time that is on, and next frame it's off. There we go. So this field force is always on now. Just where it's getting applied is turning on and off. So my mistake there. As I was saying, another force we could apply here, potentially more dangerous because you're only applying it to a. Actually, there might be fall off on it, but I think you're only applying a spring to a single point. But you could kind of make it stretchy and maybe even make it a little bit more interactive. So let's see. Yeah, so that one fell down, and now right as that one goes, this one's going up. It's going to pull up for another 10 frames. We got some ghosts. And then that one's going to let go. And the idea here is that we've kind of pulled stuff to a particular spot, so it's going to fall down and clump. So that one's clumping quite nicely. And now this one is going to fall. And yeah, already you can see how this wrinkle is traveling up there. And now it's going to have to figure out where to go. Before, this would have just been a really smoothly traveling out. But now it's got to have somewhere to go. So that's actually working brilliantly. Look at that. Look at this fold over on itself, too. That's great. It's a little bit of a puff right now. We'd have to keep giving it more frames for it to settle. Very nice. Still not quite done to go, but look at this folding. Look at that. That's gorgeous. If you were like, oh, before it was always like, oh, if you want to do this kind of wrinkles, we have to sculpt them. But instead of sculpting, I mean, we could sculpt in, we could sculpt in, which one? We could sculpt in this wrinkle here. We could sculpt in those wrinkles here, perhaps. You could not sculpt this, not very easily. You'd take a lot of effort to do something like that. So that is pretty interesting. Now what I'd love to do is introduce the idea of a spring tugging on something. This is all working well. I'm happy with that. Let's temporarily turn off the force though and see if we can get a spring to do something. What's the idea here? What I'd love to do is something like Marvelous Designer, where that I think you can almost interactively do the spring. You just click and drag, and it's like a spring is appearing getting pulled, tugging on that thing. We can't do that. We have to be very specific on how it's going to get linked to it. But let's just see where it goes. Start out by creating simulate spring. So we've got a spring here. Pull up in the air so we can clearly see it if we need to. What is it going to link to? It's going to link to nothing, which is going to be us, and then it's going to link to the cloth. Now, right now, it's the center of mass. It's going to be holding onto the overall object. I'm going to say I don't want that. I want it to be a particular polygon point. We could make a selection point, but we can also just leave it on index and drag this index around. And as I increase this, it's going to be cycling through every single point in the cloth. So I'm going to pull it to maybe right about there. So not quite in the corner, but in one of these polygons in here. Right there. Right there. Nice. All right, so we have the spring, and the spring currently has a length, and the length is going to be tugging on it. If we say set rest length, this is the actual current length. So it's going to be trying to maintain that relationship, which I think is fine. Now, we also have a concept here called region of influence, and I think that might mean there's a bit of a fall off on there, which is cool. We might need that. So let's start out by just hitting play and see what happens. Now, immediately you can see that this is indeed linked, and it's pulling that up in the air. And I think our region of influence is doing a lot. I'm going to drop that to half the amount and start the simulation over again. And now you can see that, yeah, the region of influence, that's great. This is really nice to have this kind of thing for cloth. You can now see it's just tugging on that one little spot. Now, what's very nice about doing it this way is it's going to be slow, but look, we can actually affect it in real-ish time. I can tug this around and get it moving in different spots. Now, almost immediately, you can see that thing I was talking about. Look, as we pull this piece of cloth, why are these points being affected? And I think that has to do with that bounding box thing I was talking about. Eventually, they do all go and settle, but that's a little bit of a pain. Now, if you were trying to art direct something like this, though, I could pull this over like this, let this settle in a little bit more, and then I can just be like, and turn off spring, and that should just freely let it go, and now it will just fall, although it's doing too good of a job of getting back where it was. I'm going to say, nope, you're still linked. Stop fighting and come over here. I just want to fold this over on itself a little bit. And I think that should be enough. We'll need a few more frames, so I'll pause this. 333. Hit play. And let that settle in. Now, the stiffness, we did stretch it so much, so powerfully that you see that those stretched a lot. And so it's going to be trying to stretch itself back where it belongs. But I think that should work all right. I think it's enough to be wrinkled on top of there, get this extra nice, hanging drape, and then on top it should hopefully fall on there a bit. If not, we can always reactivate our spring for a moment. Even pull it down a hair. Let's just pause and take a look at what we got. Ooh, that's looking pretty nice. This is kind of fun. I mean, I wish it was running a little bit faster. And the Marvelous Designer, I think this would be playing at 30 frames a second, where you're like tug, tug, pull, fall, gravity. I wonder if the person who programmed the soft bodies in the cinema is still at Maxon, because I'd love to talk to them about this weird bounding box concept. Because even that, I've just intuited that. I don't know for a fact that that's actually what's going on. It's just what it seems to be to me. So, well, in any case, yeah, we got, for the first time ever, we got some nice draping down and pulled the cloth on top. I mean, I guess artistically that's not necessarily the best positioning of everything, but you see the idea. The idea that a spring could tug it into a new position. And even that, I mean, we've paused it right now, but I can say, you know what, I don't quite like where that was, so reactivate the spring, and I want to pull this back into the air, hit play, and with any luck, I'm going to pull further in the air. Yeah, okay, there. That's enough for it to suddenly yank it back to life. And now that's been pulled up. And now pause again. And now pull it way over there. Hit play. And now that's getting yanked over. turn it off. But you can see how you could pause it, hit play, and then art direct it a little bit more if dragging it in real time wasn't working perfectly. But once again, the fighting the bounding box, especially it seems like the quicker we go, it seems to fight it and rotate it. So gotta be careful there. Something I would be curious about would be the follow position, follow angle that was fighting us. But I wonder if we turn follow angle back on again, if that will work. If like essentially yanking this around, if it can still settle properly. So there we go. We get some more nice draping over here in the corner. Let those gather up. So yeah, pretty fun. It is definitely intriguing. Get a lot of control over that. Now, I would really like to make it, well, I'm just trying to imagine, like, if people are using cloth, if people are doing something with wrinkly cloth, what are the things that they want to be doing with it? And, kind of make a tutorial that addresses those things. Because we could do this, but, I like making it even more practical. So follow rotation, that's what I meant. I'm going to turn on that follow rotation, and let's see if that has a big effect, or if it's going to stop that from doing all that twisting. So right now, I imagine it should just work normally, but I actually don't know that for a fact. And then activate the spring. Hoop! Oh no, it still twists quite a bit, even with that follow position. Although it did seem, well, I don't know. Let's really force it to follow the position. Do it again. Let it fall down. Begin running the sim. Starts growing, and then we say connect. Hoop. Oh yeah. Look, see the extra super strong follow rotation definitely stopped it from flipping over, but we're still syncing. So we might, if we were like twirling this thing, that might not be able to happen. But it does seem like we're able to use some follow rotation. That's stopping all of those from like twisting all the way around, seemingly. Seemingly. And what's cool here is I'm pretty sure I can just drag this spring down and make it even more quickly get tugged down. And it's just pulling it. So that's going to very quickly pull it down there. Make that run a little bit quicker, turn off the spring. And that's all going to settle. These big holes where these are falling through. Was that happening when the follow rotation was off? I wonder if that is a consequence of doing that. Let's take a look. Yeah, let's just take a look. I'm going to run the sim, not doing any spring stuff, and immediately we get kind of hole punched in, and that one's sort of maintained. Now, zero out to the follow rotation, hit play. No, it's still there, so it's not a result of it. I don't really remember that happening quite as much earlier, but yeah, I'm curious where that came from. Now, especially for anybody who wasn't here yesterday, the problem areas that we're getting with that, we can try and fix that with some of these little spheres. And by just scooting these around to little positions. Like if it really seems to be a problem right there, by putting a little sphere there, you can see it just poking out that tiny little bit. We shouldn't really be able to tell a problem with the cloth. And if we want to get real specific, we could grab our straight spline here, and along with the cloner that it's associated with, paste both of those. And now I'm going to grab this point, and now you can see I can move that there. I'm going to invert to grab the opposite point. These are just a spline with 2 points, and now you can see that I've now got a stripe of spheres. And that stripe of spheres should hopefully stop the middle point of this from being it. These are bigger spheres. You just can't see them. They're as big as these. And yeah, just by doing that, creating a couple spheres, I don't, at least with our test, we were seeing that it didn't really have much of a speed hit because the spheres calculate really quick. And there we go. You see immediately that prevented it from popping through because those spheres are just calculated a lot more accurately. So yeah, pretty handy little extra thing. I wonder if it even goes to like grabbing, you know, there's got to be some slowdown on it, but the basic idea of, let's see, what would be the best way? Because yeah, we made the two edges here. So I wonder if a nice not proof of concept, but a nice workflow on this, if your text isn't changing or whatever the thing is, the model that you're feeding through. I'm going to copy and paste. Actually, why does it keep jumping? It's not animated, so why? That happened to me when I opened the scene file. If I copy the text and paste it, why is it going to a different position? I don't understand. It's not in the null. Look, it's completely different. I don't understand. What if I duplicate? Oh, even if I drag copy, very frustrating. I don't understand. And it's not dynamic. It's a dynamic collider body, but it's not dynamic. Well, that's interesting. If I make a child and zero out the PSR, that's not moving either. Freaky. Reset PSR. Interesting. Delete dynamics tag. Reset PSR. What? Is there some sort of effector affecting it? No. Well, that's just downright bizarre. Oh, great. Now they both move to the new position. I'm just going to chalk that up to some Cinema 4D weirdness. Okay, well, now the new one is able to be copy-pasted. All of that should have been relatively simple because all I want to do is make this editable and then go to edge mode. We have to make that editable. Go to edge mode, and now I can do a loop here on that perfect edge. Shift C, type in the word edge, and then you can see edge to spline. Enter. And that gives us a spline. And this spline, cut, close, paste. Now we have a spline perfectly traveling there. And now if I copy and paste our cloner, I could clone onto that spline. Boop. And now we're going to get these occasional spheres traveling around the entire thing. This will have to, actually, what would be nice is instead of moving the spline, I like the spline being where it is actually supposed to be. So in the cloner, we can go to transform and just say, hey, go down a little bit. And I guess they're a little big for the edge that we're on. So we could probably, yeah, I think we can just pull them inward. On Z, no, Z travels along. So it's also on X. So on X, I would push them out. We can go in a little bit. So in and down 5. There. Now they're around the edge. You see them traveling around the edge. And of course, the cloner makes it trivial to do something like set this to step. And now it's going to be creating one every certain step. So we can keep on decreasing our step size. And it's going to make more and more of them in a very even manner. And the goal here is not to make like a million of these. It's just to add in enough of them to be like, okay, every once in a while, there's this impossible point that it cannot escape from. And just that handful of spheres, hopefully going to work pretty well. This corner one's not working quite as nicely. And I'm just going to offset until that one is not in that particular position. And there we go. That should do something. I should grab the, as long as we're doing the effort, I closed the file, so I'll still go new, paste. I copied that. We're learning, so let's just do it right. Make that editable. Make that editable. Edge mode, UL, loop the midpoint there, the midpoint there, and the midpoint there. Shift C, edge, to spline. There's our spline. Copy, paste, go away, new. There we go. Those are spinning the wrong direction. That is not unusual, but I have to select those splines, select all, UW, right click and say point order reverse sequence, and then and then frame forward, frame back. But they're still traveling inward. There's always something else. It makes sense. I mean, that's not wrong. The reason they're doing that is because of like the rail. It doesn't, because one was traveling inward. One's an inner spline, one's an outer spline, and that makes the difference. So these are pushing out instead of in. Technically, they're pushing in, but because we're on the inside, we need them to push out. So that's correct. Richie, hey, thanks for the thing, the little, I forget what that's called. I actually enabled that recently just as a, dang it, what do you call it? It's a super chat. It's my first super chat ever. So thank you. And I appreciate the kind words. So there you go. You win the first super chat ever award. Thank you. But in any case, I was trying to make this really simple here. It was being a little bit more of a pain. We could create some outlines. We could also just hit UP and split that into a new spline. And now we have two different splines. And now one would be the inner, one would be the outer. Do that. And one of them, we just have to tell this to travel inward instead of out. That's the inner one. Looks like the spline still has. Oh, this throws me off sometimes. Why do we have two sets of them? That is just that, and then this is just that. That makes sense. Spline. You follow that. You follow that. Turn them on. There we go. I feel like one didn't refresh when it could have or should have, but whatever. Now we've got a little bit of extra detail as they spin around one side or the other. Like that. And that should just give us that little bit of extra detail, which is going to make them not escape. Now we can unhide our cloth, which was actually there the whole time, and drop and oh, I deleted the dynamics tag off of the text. I was like, what? How did everything get worse? I accidentally deleted. Well, I didn't accidentally. We were trying to figure out what was wrong. I don't think we have to change anything. I'm just going to leave all that default and hit play. And now you can see all of our edge problems seem to be solved. That was a little, well, the way I did it made it seem longer than it should have, but it's a relatively straightforward technique, and we can now see that there's a hint for a moment of it trying to sneak through. And before, I actually did make note that the FPS was 1.7, and it continues to be 1.7. So the spheres calculate very quickly, all things considered. And then we can turn on our spring. Actually, that's, where's the spring living? That was dangerous. I guess that's a fine location. It just tugged it up there. Now, I mean, it sucks a little bit that it takes this long to calculate. And you see, it's only like 100 frames. That's not very much. It's not having to fight too hard to do this, but it's still, our FPS is dropping a lot to make this happen. So if we baked it, although I gotta say, baking soft bodies can be weird. If you bake it and then put it into a soft subdivision surface, it can break it. So our slightly better bet here might be, I'm just gonna do, let's go to 140 frames and save it. E, and let's bake it to Alembic, which is super easy. We just right click and say bake to Alembic. What's funny is that Cinema had the ability to bake to Alembic for a couple versions, but you had to export the entire file, and just the idea of being able to do it with an object instead of the entire scene file changes how you think about it on such a fundamental level. I'm always fascinated by, it's essentially not new functionality, but because we suddenly have a slightly new context in which to do it, you start thinking of it completely differently. I feel like that's one of the most fascinating aspects of making tools, is that sort of idea. It's pretty interesting. Whew. Unfortunately, these will slow down as they go. In the beginning, it's not colliding with anything, so it runs very quickly. And then as it collides with more, it's going to take longer to calculate. But I think the entire point of doing this is just so we can see it in real time. And if you did have a slow computer, then you could just bake your dynamics or bake to Alembic and be like, oh, that's what it looks like. It just sucks you have to do the calculation again and again. But keep in mind that if you go back not too many years ago, that they didn't have the controls to see this stuff in real time at all. So movies were made with processes that were clunkier than having to do like an export check it kind of thing. But in any case, I think we have to pull that off. Oh dear. I'm not sure what's going on. Let's pull that out dynamically. I didn't think that would apply to anything. I'm going to just make a null. I put the dynamics tag on that so it's not actually doing anything. There we go. Now we're in real time. Blurb. And now we can subdivide that nicely. And we can see in real time our simulation. Still escaping a little bit. We can increase our sphere count, of course. It's pretty nice. I'm trying to think, what is I'm not trying to think of okay, imagine if there's somebody doing some work and they need to do some cloth. If somebody's doing some work and for a client and they need to do some cloth, what are common things that people are going to have to do? Like when you're trying to do this kind of like, oh, I need some nice looking wrinkly cloth. What are the common uses for it? Not what are some crazy weird out there uses. What are common uses? Because what I'd like to do is think about the common uses that might be done on this kind of thing, and then try and address the common uses. People can always go crazy with their specific off the rails versions, but what are the common uses? Now a couple extra thoughts, straightforward things. Let's delete the baked version, run the simulation on this again. We're already playing with field forces. Why don't we increase our sphere count? Because why not? I will double it. Lucas, I was about to. Curtain unveiling. That's an interesting idea. We haven't pinned this at all. But what I was about to do is, let's see, what do we need? I'm going to grab. We're getting so many items in this. A little bit of cleanup is probably warranted. Let's call this spheres and everything involved in our sphere helpers. We'll go in there. And I was about to play with the springs some more. So if we make 4 springs, let's see, what's a good way to control this? I'm going to make a plane. Let's make it red just so we can see it. So on this one, I'm going to make it only 1 polygon by 1 polygon. And I'm going to put a spring as a child of it. And this time I'm going to say that it is the parent. And it's going to start on index 0. So that's on... this is on polygon point, and that's on point 0. So point 0. So that's point 0 to point 0. And then... and I guess we can be a little organized. So point 0, and I'll make another one. This will be point 1. So on this one, polygon point 1. And now let's just increase this index until we get the equivalent, which is going to be there. 50 points, not surprising. And the 4th one. This will be point 2. Now this one will be crazier. So it's actually the opposite corner. So it's probably, it's going to be a big number. Probably like 2,500 minus 50 or something like that. Yeah, that's what my guess is. 2,500 minus 50. Actually, it's a bit of a floater right there. I thought our total point count, actually no, that was polygon count was that. So our point count goes all the way to an extra 50. Okay, I guess that makes sense. So it's plus 50, not minus 50. And a third one, which is actually the fourth one. And that will be 0.3 and will be another 50 points. There. So now we have 4 springs all directly connected to the 4 corners. What I'd like to do is right click on this plane, go to render tags, display, use lines, and now we just get this nice outline. And the goal here, and we can even grab these springs, display a thin radius. I like seeing them in this context, but I want it to be really thin. Always display, so even if they're off, we'll see them. So this becomes sort of where they're hooked from. What's cool is if I hit T for scale and scale this out, you can see that those are all connected via that. So let's select them all, and I'm going to set the rest length to 0. All of these points are trying to get to the corner. They've got a little bit of a region of influence. The top one has a region of influence of 0. I guess 1 it needs. The top can have a little bit of fall off. But I'm going to make the stiffness quite weak. I'm going to put the stiffness down to 0.1. And we will save this because it could explode and freeze. You never know. Wrinkle test. Springs. So now we have 4 corners. I feel brave, so I'm just going to hit play. Okay, that seemed like a bad idea. I'm going to immediately pause it again because nothing seems to be happening. Oh, goodness. All right. All right, all right, all right. It didn't like something about this. I'm going to set the rest length back up and put the stiffness back to 1. So that should not freak out too much in the very, very beginning. Save it again. Hit play. Okay. It did not like the cranking up the... cranking the springs down to 0. I think it was dragging it out so far that it's just exploding the cloth. So we got to be careful there. So this is holding all of the corners up a bit, and now suddenly it's going to expand, and these are going to start wrinkling over. Now is what's we've got these 4 corners controlled. It's kind of pulling all 4 of them out, but we should have a decent amount of control over how this kind of. Oops! Did it explode? Yeah, it's exploding. Got to be careful with the exploding, the reason exploding takes a very, very long. It starts like going incredibly slow in your scene, is because suddenly a bunch of polygons are intersecting, and it has to calculate that frame. And every time a polygon intersects, it has to work harder to do the calculation. So that's why that actually takes a long time. So all I've done was scoot this over the side. So in theory, this is going to try and pull everything over a little bit. Oh, it's not. Wow. I might need to keyframe it there because the spring, and we're getting to the point where the springs are not cooperating. So we got to be careful there. And I like I said, if this is going to be a tutorial, it's got to be the intuitive parts of things. So over the course of 20 frames, I'm going to scoot that over quite a bit. So frame 1 is not pulling it to some impossible place. Whoa, 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 whoa. What is that? Well, this is not cooperating very much. 1 frame, 2 frame, 3 frame. What is this? What is even happening here? I see no logic in that. Let's temporarily turn off the text in the current circumstances. That's not doing anything. Yeah, look at that. Why would that do that? Hi, Paul. Yep. We're trying to push the cloth stuff further, see if there's a tutorial to be found in this. So with 4 springs all set to the exact rest length. Yeah, the exact rest length. Why does that suddenly go blurp and fly all crazy? Now we got to keep in mind that we did make that one. Oh, we have the floor back because we undid so many times. So we do have a floor. So that should be nice and infinite. 1, 2, 3. There's nothing here except for this stuff, right? I'm inclined to copy everything relevant, that, and that. Copy, new, paste. There we go. Nice new clean scene file. We'll save it as G. Just to clean everything up. 1, 2, 3. All right, so with only these things, that spring still wants to do that. Go figure. And I'm going to kill the keyframe. 1, 2, 3. Okay, well, the keyframe definitely seems to be something that triggers the outburst. Kill the floor for a moment. Let's just play with this and hit play. Let's see if this cooperates at all, for how long. So that stretches down. That's all fine. It's doubling in rest length, which means there's like a whole bunch of extra geometry in there. As tension is applied, I would think that would flop downward. We should turn off. Oh, okay, the follow rotation is off. Powell, greetings from Portland. Greetings back from Chicago. Play. Whee! Okay, so that's all off. Now, the part I'm curious about is why is this not drifting further downward? Unless it kind of is, and it just doesn't visually look like it. Like, are these... I guess it slowly is. Not super visually intuitively, but it is. Alright, I'm going to keyframe the rest length, and then over the course of 25 frames, let's have the rest length go down to 0. Play. Very, very jittery, but it did pull it off. What's interesting to me is it's behaving a lot like... There it goes. Boom. That's too bad. Portland. Oh, Poland. Greetings from Poland. Greetings to Poland. Back to you. Now, this is the kind of circumstance where I really feel like it starts getting to the point where there's only... Well, I mean, we only have like 2 variables we can play with. We can play with the damping to slow that down. Potentially, even though it's not where it exploded. And then, actually, I mean, depending on what you're doing, if these aren't super intersecting, we could turn off self-collisions. Let's see if that gives us more speed in this circumstance. And it should definitely stop exploding, because this exploding is almost purely a result of intersecting... Oh, no, it still exploded. Well, springs also explode. What can I say? In fact, this is why I'm reluctant to use springs. And it was cooperating so much, it almost made me forget for a moment. But springs can get twitchy. They can definitely get twitchy. And one of the ways they get twitchy, or in the way that they get twitchy, there's no setting to make it more specific. So the only thing we do is go to expert and start cranking up our steps per frame. And like I said, I hate doing that. Like, we can double that, and this will probably work better, but that literally means it's going to take twice as long to calculate each frame as it was before. Now, in the terms of overall render time, maybe it's not that much, because we're taking, you know, it's going from 1/4 of a second to 2/4 of a second to do the calculation, and your render is going to take 1 minute per frame, so maybe that doesn't cost that much in that circumstance. And yeah, you can see that now it didn't explode. It didn't explode because we just gave it more steps per frame. Not the happiest type of setting. Let's try a couple more keyframes. Those are stiffening up to pull in the corner, but let's see if we can... I'm going to record some rotation. Actually, I guess it takes 25 frames to get to the corner, so we'll start the rotation there. And over the course of another 25 frames, we'll have it spin 90 degrees, not too much. 90. All right. I don't see any reason this wouldn't work. That jitteriness in that opening part's kind of crazy, but you gotta keep in mind. Whoa, okay, apparently there is a reason. It's linear. Oh, Gumbo and Lucas. That is an excellent question. A real-world application, wind blowing cloth off to get a product reveal. That is an excellent, excellent question. We will tinker with that after we run this through. So let's see. Okay, well, see, that one's exploding the instant it starts rotating. Very frustrating. Now, let's just push it further. I'm going to double our steps per frame again. Also, if you go too much above 55 steps per frame, it can get twitchy again and start introducing more exploding. So we're not out of the woods just, yeah, that didn't work. So let's jump it up to the 55. So now it's going to start really taking its time to calculate each frame. Right here, and now it's going to start rotating. And okay, now we're at enough steps per frame where I was able to handle at least that first part. So here, literally the only setting that we had that would do anything was steps per frame. So yeah, just cranking that. But the point here is that there's no belt. Cloth, the one advantage cloth has is it has something called belting, or you can fix points, and you cannot do that with a soft body. Literally the only way to take a point and link it to something else is to use a spring, and springs are very, very twitchy. Like, I would never want to make a character that you had to connect 100 springs around his belt to make the skirt stay on. Like, that's just insane, and they tend to explode, and we had to jump this up to 55 sub-steps until it worked. I would like to run one more test, which would be putting that back down to its default 5, and I'm going to crank up the maximum solver iterations. I feel like this is the kind of situation where solver iterations could go a long way. Nope. This starts out with a larger number, so I'm going to go 5 times as strong. Nope, exact same explosion, so that needs the same one. I don't know if that actually does much to help, but yeah, interesting nonetheless. I guess we can save that as this version. Okay, so the idea of using wind to do a product reveal, I like that idea. So two things, maybe actually there's a couple things that I think could be neat here. So we're going back to an earlier one that we should have just nice simple simulation going, which is all working nicely. So that's going to fall and cover our letter, and it's going to grow and get all wrinkly, which is pretty much exactly what we want. So here's a thought. If we bake this down into a mesh, so let's just say that it's like, okay, cool, we've got our product covered perfectly, and that's the way we want. We want to start from that position, is what I'm thinking is a nice goal here. Now, is it possible? Is there a checkbox in dynamics? I always forget. Yeah, you can set initial state. So if I say set initial state, then that is what it looks like at the time of 0. Now if we hit play, it's going to continue settling. Whoa, oh yeah. Oh, it's it's suddenly, it's cute. It's suddenly going back to 100% scale instead of 200% scale, which is funny. And it's going to grow again, so that's entertaining. But the bigger point here is if we were to take our dynamics tag off, this just becomes the mesh. So that just is what it is. So that's the way it starts. Fair enough. Works well. Actually, kind of curious, but let's save this again. Cloth wrinkle test product reveal. By the way, Gumbo, that is I couldn't think of something. I was like, I feel like there's a practical application for this, and that is literally the perfect answer to that question. Where it's like, okay, that is a tutorial doing a product reveal from that. It's the kind of thing where it's like you put that out into the world, and you suddenly feel like you're going to be seeing a ton of commercials that are doing that because suddenly everybody's like, oh, that's a cool new effect. I'm going to do that. Whoa, ho, 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 ho. Oh, that sort of makes sense. That's suddenly popping up in the air because I dragged the dynamics tag to the motext. Although I gotta say it's frustrating. I'm jumping back to 0, and it looks like the mesh. What happened to the text? I guess I made it soft body, but I'm rewound to frame 0, and it's still broken. So if I say, let's make a null. Like, did this motext like permanently break from that? Well, I'm gonna revert. You gotta be careful. Oh yeah, whoa, revert. I forgot I had just saved it, so we can rescue that. Null. Rink. Yay, I rescued the text. Okay, so this mesh is now, I think, permanently that way. And we just saved it. I'm going to save again. Now, if we drag this back on again, then now it's like, oh, that's the new position. Currently, the rest length is at 100%. I'm going to stop that from keyframing. So now everything just is what it is. In fact, I almost feel like we should say shear and flexion are 0. Petrie, good point. I possibly had to release the initial state that had confused it, but we're back. We're seemingly back. Okay, so now this is the initial state, and we sort of baked it down, and it's not the initial state from the point of view of being grown to 200%. It just is what the mesh is. So now we've cleanly put the dynamics tag back on it again, and now when I hit play, I would expect to see it relax a little bit more. And I think I had accidentally killed the dynamics tag on the motext when I dragged my previous one on collider body. So this is just going to, if we hit play, it's just going to settle more, which is both a good thing and a bad thing, because the other one wasn't completely finished settling. So this is using all the same rules and continuing to try and settle. And if you truly don't want it to be moving anymore, I think we'd have to just let this go and go and go until it's like, okay, it's not moving anymore. And then, I mean, is it as simple as just pulling the tag off and now that's become this new permanent model? And then if I'm just going to save it again. If I rewind, hit save, if we drag this back on again, it should be as if we made a new tag. So that's just the initial state again. And we hit play, and yes, there's going to be a tiny little bit of movement, but it's not going to be like a ton. Although it's going to keep on relaxing more and more, so you do have to be careful. So let's just say that that's our initial state. We might have to add keyframe some stiffness. We'll worry about that in a little bit. Right now, I just want to deal with some sort of reveal. Now, the very, very basic version of the reveal would be, I think, to make... Let's just do a spring. We're just going to put one spring in the center and yank it up into the air gently. So that sounds good. Let's try that. Simulate, dynamics, spring. Once again, if we don't put a object in the first slot, it's just wherever the spring currently is. Object B will be our cloth. Cloth. The spring has a nice large range, which is fine. Center of mass, I'm going to say polygon point again. Point somewhere towards the middle. Right there, good enough. Scoot that over. Okay, excellent. So set rest length. Oh, that was incredibly close to the original number. All right, so that is that. And now it should start exactly here. And we say, hey, that's the product reveal we want. So keyframe on Y. 60 frames later. It'll be, yeah, let's just go pretty far up. And that will accelerate in, but that's fine given the current circumstance. Save. And I can't think anything except for hit and go. So here we go. Now the idea here would be, yeah, I guess it just kind of reactivates. Hopefully it doesn't settle too much. You want it completely settled. But let's just see how well this pulls up. I'd also be, let's see if we can get that to, yeah. So we're going to display this. The hope here is because I turned off all the flexion and all the shear that the polygons are not really going to stretch. They're all going to be pretty much maintained. And these can all go back to approximately the same shape, even though they have no original relationship to it. Now, well, first of all, that's working incredibly well. We just need to go a lot higher with this. So let's give ourselves another 30 frames. And let's make it even a little bit more interesting. I'm going to make an arc. Now, let's not make an arc. Let's delete that arc. View this thing from the side. I think this side. And I'm just going to draw a spline. So I want to start here. And it's going to pull out this way. And then pull up this way. And kind of keep going that way until hopefully it's kind of out of frame. R for rotate. Get a nice clean arc. R for rotate. There we go. I just don't want the lines to curve inward, so you get a nice smooth arc. All right, so that's all right. It's not exactly the angle I was aiming for. Where's this? Okay, the center's in the correct spot, so I can spin this 90 degrees. Excellent. And we've got our spring, which is pretty much already exactly where we want. So we can say animation, align the spline. The spline is going to be cloth path, keyframe, time of 0, position, time of 100, 100%. That should be kind of all we need to do. Save, play, and now it's of course going to pull away and then up. And hopefully now it goes far enough. I like the angle. If we put a little bit of drag in here, it might do a really nice arc as well. Thinking about it, we probably want to really lower the friction. No reason for this to be catching anything. I mean, it's completely uncovered it. We might need to scale it up. I'm trying to think of settings I might change to improve it. Some drag could be nice, but stylistically it's going to dramatically change the way it looks. Pause, create a null. This is not the scene file that we cleaned up all of our spheres. Okay, so it's pulling. It's doing a nice job. And I think it will pull it completely clear, which is fine. I'm going to add a bunch of drag. I'm not sure what effect we're going to have. Cloth. Cloth, I'll keep the friction. The text, I'll get rid of the friction. No friction. It can just freely slide off of that. But the cloth itself here, that will get forced drag, two-sided drag. We know a little bit goes a long way, so 25 I feel like is actually a huge number. Let's just see. Not much to do except for see what it does. I am trying to think of... I guess we could turn off gravity and then it wouldn't be trying to settle. We could turn off gravity for the beginning. And then once this starts moving, everything moving a little bit wouldn't seem weird. We could potentially animate the influence to grow as well. So I don't know if you'd want to have it just pinched in this one corner or if you'd want to have it get stretched. Now the drag, I would hope, would make it so that these would all travel the same line. Now that first point isn't quite getting there. I think we'd have to exaggerate that more. Like I say, visually it's not terribly different. I feel like the drag is causing these to look a little more pointy and streaked. Not necessarily a bad thing. In fact, I think if you've got this kind of, I didn't even think about it, but if you have this kind of cloth dropped over a shape, I think it's usually a circular cloth. It's not square because you don't want these points. You get really nice, yeah, this would be so much better if this was a circle. So let's keep that in mind. Really long frame. There might be, nope, it handled it. All right, we learned some new things here. That's all fine. A couple things I would like to do. Our cloth path. I feel like we should exaggerate it. So I'm going to T for scale. Actually, on the overall model, I'm going to scale it more like that because I want this to go further that way before it arcs upward. It's also not super smooth, I think probably because of the subdivisions. So I'm going to crank that up to the angle down to 2, which puts more subdivisions. Okay, and then look how foggy it gets for some reason. Oh, not for some reason. There's an environment in there. And I did that because it made the screenshot look better. Actually, I kind of like that graying everything out, so we'll leave it. Okay, that's going to pull it up, travel over. A circular cloth. Should we try and make the circular cloth? I think it's a good idea. Like, just to make sure all of this rig concept stuff is working. Now, if we're going to make a circular cloth, we still want it to be square polygons for as much as we can. So let's set ourselves up well here. Pull this up. And then we're going to be chopping off a lot of polygons. So we can, before we are 55 by 55, I'm going to jump it to 65 by 65 this time to be a little bit more. We're going to make this a little bit bigger, and I want these to be square. So would it be better to do like a circle with a Delaunay subdivision or quads, or just take a bite out of this with a bool? I'm thinking a bool. So just do something real straightforward like that. I don't even feel like we need this to be overly subdivided. I'll go up to 36, but I don't think we need that many. It'll create more straights here, but that'll minimize extra points that we don't need. That's the thought anyway. Bool. Take a plane, take a bite out of it with a cylinder. Strike that, reverse it. And we want the intersection. That's what we actually want. There we go. And create single object. Technically, we probably don't even need to make this editable. So, yeah, we'll give that a go. Do something like this. Do something like copy that over. We'll keep it a nice cloth. Delete the original. That's just a few frames above. Pretty well centered. Cloth. Nice. The only thing we need to do is get the growth going on there. If I recall, it was something like at frame 25. I could be wrong on that. It might have been frame 15. I'm holding down Alt as I go to the time. At this time, the rest length is at 100, and then at the time of 50, the rest length will be at 200. Keyframe, rewind. Nice. Everything's going well, so I'm just going to save it as another version. In fact, we'll go to 2A. Okay, that's all fine. We should be able to hit play, let that fall down. This object isn't going to have the spring attached to it yet, which is fine because all we're doing is pre-building. A couple things I'd like to test here. If we hit play, then it's going to fall. Very nice. Very nice folding on there, and then it's going to start growing. This is all still the same dynamics, isn't it? Why does it seem so... Oh my goodness, so important. The friction on the ground and the friction on the text, which we turned off, very, very important. I was like, why is it just flowing off of it? It's like, well, there's no friction. It's not trying to stop it from sliding. Yep, now we grow. The wrinkles are getting introduced. The edges are pretty good. It's a little, it's actually, I mean, the circular cloth drapes a lot more. Like, look how perfect the coverage is. Almost too perfect. It's kind of ridiculous. Is that all zeroed out? Yeah, it's zeroed out. So I'm going to recenter this text on it a little more, like that. I suppose the spheres need to move with it as well. Apparently I forgot to put that in. Whoops. Save. Oh, when we need the initial stuff. Yeah, actually, this was part of the test. In the cloth, we used to have a shear of 5 and a flexion of 5. I think that makes a big difference. I was like, the wrinkles don't feel the same at all. There we go. Very different if we have a little bit of that. Yeah, there you go. I knew we were missing something. Come on. Beautiful. Look at that. Cloth in there. Turn it on. Take a look. Lovely wrinkles. All right, so the idea now is to save, and then let us see if we can set initial state. That's it. Set initial state. Cool. Now, inside of our rest length, I'm going to say, go away rest length. You are 100%. Now, if we rewind, hit play, what happens? Is it going to... Yes, it is. It is reverting to its scale of 100. So if we say, no, rest length, you stay at 200, then this is just where it is at the beginning. Excellent. And it doesn't change at all. Now, it is still settling. That's to be expected. We don't actually want it to continue settling, but that's fine. We're just, that's the step that we're at. I almost feel like we just leave it settled until the boom, you kick in the spring activating. The spring should be connecting itself to the cloth. Which point? I don't know. It's a little fiddly here. Yeah, that's, nope, that's not it. I'll go to the top view. That, nope. Oh, yeah, that does work, sort of. There, that's a nice one, right there. Okay, so this is now connected. Set initial length. Nice. That will begin animating right away. And you know what? I know before we said it was spline was fine. I'm going to say linear. I want it to start accelerating away right away. to a degree, I almost wonder if we will do a test where we turn on gravity and one where we don't. But now, the set initial state worked awesome. So far, seems to be carrying through. So now that's already keyframed. It's got a bigger arc. Let's just hit play. The spring is already linked and should immediately begin its journey. I thought it would begin this journey. Let's double check. Okay, it is traveling up, but it is giving it's a red spring, saying it's a broken spring. And that broken spring, let's go 1 frame forward. Yeah, 1 frame forward and it says it's broken. That might be because it's not editable. So we tried to leave this in the cloth. Maybe that was a bad idea. So just to take a step back, keep everything clean, let's clear the initial state. We're back to the beginning. Turn off the spring. We don't want that. Make this editable. So now we just get our single mesh. Don't need the selection. All right, now we have our new cloth. Let's just run the simulation again. We lost the scaling, unfortunately. 200%, not too hard to do. Alt 15. Well, this guy, what we're doing right now is learning the steps we need to take. 200. Once again, I'm holding down Alt as I drag my timeline. That way it's not refreshing. Otherwise, it'd be doing a big calculation on the dynamics. All right, so now that is keyframed. I think that's the only thing we need to do. Hit play. Let the dynamics run until visually we like the look of them. Beautiful. Even though that's growing 200%, I almost don't even feel like... It doesn't feel like it's growing 200%. Maybe it feels like it's growing a little bit, but I'd have to see it in real time to know for sure. But that's pretty good, I gotta say. All right. Nice. Set initial state. Nice. And now, turn on the spring. That should still link to the same spot. Rewind all the way. It's at 200%, but now we do need it to not be animated. So turn off the keyframe, go to 200%. That way that's what it currently is. That's what it should maintain. It's going to start animating right away. Save this as C. And we can get rid of all the friction on the motext. And do we have any drag? Could have had drag the whole time. Yeah, we had drag the entire time, which is interesting. Didn't dramatically change the way it dropped. Let's just hit play and see if we start seeing a reaction right away. Spring. Oh, link. Okay, there we go. I can hit 1 frame forward and see if it turns red. It didn't. Good sign. All right, hit play. Actually, just to be safe, rewind, save, and then hit play. All right, here we go. We've got some drag. We've got the big elongated thing. It's from a set initial state, which means we still have the original geometry, which means its original polygon state is still stored, which is also a really fun addition. Okay, got a nice pull going. The influence is like a percentage. I wonder what that percentage is keyed off of. Is it based off the radius of the polygon? Is it based on, oh, like everything's getting pulled up. What did we do to fix that before? Maybe it was extra heavy gravity. But you see how everything's getting pulled? And that's, once again, the bounding box issue. We definitely need it not to do that. Yeah, that's an issue. I wonder if that has to do with breaking the initial state or leaving it fresh. Interesting. Gumbo. These are only they are posted, but only to people on Patreon. Like usually this would only be for people on Patreon. But here, and here's the thing, I'm planning on making this as a tutorial. So you will see this on Patreon and then the finalized tutorial here. But of course, that's when I dissect everything and I kind of just boil it down to what we specifically need. So very different. Um, but in any case, this part, the shape is bothering me. So now we need to do the test, which is if we take that off, that is now essentially baked down. So now we say rest length 100, and then we put it back. Is it as simple as that? I don't know. So we've done that now, which means it's an initial state. There is no initial state. In fact, I mean, I guess there might still be an initial state stored on this. So let's pull it off. I'm going to say clear initial state and then put it back. So there we go. There should be no old information on it. There's no follow happening. We do have some drag. Hit play. And now it's based on just this new version of the mesh. And does it not pull the entire bulk of it up now? Or does it? There we go. It takes a second for it to initially go. I think the spline could be a little bit lower and then shorter. The length could be 0 because right now the length is 134, I think. It's all getting pulled up. And that goes back to that old problem. Yeah, thanks for hanging out, Gumbo. See you next time. See you on Wednesday. But yeah, this whole thing's getting pulled up, which is fundamentally different than what we were seeing before. Before we had a really nice tail hanging down. So this is terrible as far as that kind of thing. It's blasting off like a rocket instead of leaving those behind. Now, it's a pain. I'm going to go back to, just as an experiment, we'll see what the follow rotation does. You can already see it. You see it's twitching back and forth a tiny bit. It's only like a pixel, but you can see it wiggling a little bit. But I am just curious to see what this does when this pulls it here. Because it's saying, no, you have to stay in this position. But this is saying, well, I'm going up. Good so far. Good so far. Do you see how, look at that. This is so weird. And this is what goes back. Do you see as it's getting pulled that way? There's almost a vibe where all of these are slightly getting pushed back the opposite direction. And that's the same thing where this follow position is now saying, no, stay there. But now there's like this equal opposite reaction going. So there's like this drift that's propagating through the entire thing. Very strange. So it's the thing that annoys me most with trying to do any of this advanced soft body stuff. I just don't understand. I don't understand why. I'm going to say definitely the strong follow position is not good. That doesn't work. Get rid of those. I'm going to try putting a really high damping. See what that does. Kind of feel like it's not going to do much, but let's find out. Sky X. I think initial state is just what the mesh was at the beginning. And right now, it is what the mesh is at the beginning because it's on it's as if it's on a brand new object, in which case it's just like, oh, this is the initial state. I could click the button. I don't think it will do anything. This all has to do, I don't know if you were here earlier, but it all has to do with that like invisible bounding box and the center point of that invisible bounding box moving. And as that center point of this bounding box is trying to be center on the mesh, it's automatically pulling everything along for the ride. When we tell the follow position to be on there, then it's counterbalancing, pushing the other direction, and it's leaving. This stuff is starting to wrinkle the wrong direction. So this follow position is doing nothing. Nice try. No good. I'm going to turn off Accurate Solver just to see what that does. And maybe just for a speed boost, I'm going to turn off collisions. I don't think that changes anything to do with the bounding box, but it should go quicker. Okay, yeah, you can still see the... I mean, it's running a lot quicker without the worry about the collisions, but exact same center point bounding box problem. Turn back on accurate solver. Center point is changing. Very frustrating. Okay, so now we can go back to when there's settings in the rotation floor you can set for the initial draping that need to be turned off. Blue tone. No. Right now there's just heavy friction on the floor and no friction on this, so they're just purely collider bodies. So there's no settings on there that's going to have any effect on this drifting. This is all about the problem we're having right now. It's all about the stiffness on the cloth. Now, this goes back to what we were talking about earlier, where you get that one, you have like a polygon, a shape that you need the bounding box to be big enough to contain everything. So here's my thought right now. I'm going to just make a cube, a nice big cube. So here's our cube. If I move this far enough into the air, let's do it like that. I'm not even going to worry about, no, if it starts falling down, the center point changes. Because here's what I'm thinking we need to do is do something like make this box, and I'm going to put it inside of this, make these both editable, say connect and delete, and now they've become a single mesh. So that little box is part of the overall simulation, which is fine. And then if I put the dynamic tag back on again, even if we, and just for fun, let's hit initial state, although I don't think it does anything. Let's see if our spring is still connected to a good spot. Springy. Where's the spring? Oh, it was a new object, so it got deleted. Boom. And yeah, because we have a couple more points, that's not quite in the right spot, so we'll put it over there. Good enough. Set initial. All right. Now, there's a cube way up in the air, and in theory, that's going to start falling down. Let's do it zoomed out here. That cube is going to start falling. Yeah, you can see it's going to start falling. But that bounding box, it is now making a very large bounding box up there. So even as that starts falling, my theory is that the bounding box here is not changing, which means this stuff on the floor is going to behave a lot more the way we want it to. And if that's the case, then you can see the absurdity of the overall situation. It's staying better on the floor. It's still not perfect. Oh, that's because it's traveling left now. It's staying down, but it's going left because the scale is expanding left. The bounding box is getting bigger over there. Now, it is still blasting off a little bit. You can see the base has got way too much uniformity. Oh, why? Richie, that is a very, 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 very good point. That's a very good point. Before we have shear inflection on, but more importantly, it's not the shear inflection, it's the damping on the shear inflection. And that maintains the shape and drains the energy out from them being able to bend. That is an excellent point. So I'm going to put those down to 0. So now there's no energy drain whatsoever. And to clean up this test, I'm also going to delete this box, which is just some polygons. Select, convert the points, delete. Actually, I forgot R20. What is it? Delete. That's weird. Okay. Our spring is still connected to something pretty good. Okay. So yeah, that drag on there might have been doing something. So I'm gonna get rid of that box, even though I think we still might need that box. Let's see if that does something better. But yes, very, very good call, Richie. is the overall bounding box going to drag these up? Oh, it's looking good. Richie for the win. I forgot the really high drag on that's going to make a huge difference. Okay, we're exploding a little bit, but that's fine. Are we... Oh, self-collision. Well, it's still exploding, but we have no self-collisions, which is... Whoa, it's gone. That's fine, that's fine. Yes, self-collisions. Yes, accurate solver. Okay, now it's going to take longer to calculate. But honestly, all we really care about is here. You got your product reveal. It's really the letter that we care about. So suddenly, this is getting tugged away. Do, 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 do. Hup, hup, hup. I can't believe it's just the damping. Thank you so much. I hope that, well, in a way, I would be very happy that if I'm fundamentally wrong with that center of the bounding box point, I would be so happy because it's one of the most nonsensical things to me. There might be a very good logical reason why it happens, but like it's just so nonsensical as far as being able to try and control something in an advanced way. But now this is just getting left behind so nicely. Now keep in mind that this is like only going to be 2 seconds that this whole thing gets ripped off. So while it feels like it's taking a long time here, the wrinkles are looking pretty nice as they go down. It's a circle, so we're not going to get all those really long tails on it. We might get a little bit where they fold over, but that's kind of what you want. And we have a product reveal. Now it's cool. I mean, right now we're just driving this with one spring, but we have 2 different springs pull. And we're in there if the cloth is exploding. We might have to put a couple extra frames per second to get it to not explode if it is exploding. And I don't know if it is exploding. It might not be. Ta-da! That's pretty nice. I like it. I'm going to drop this to 80 frames, and we're going to bake this out as a lembic and see what we get. I'm excited because it suddenly started sort of working. A, B, C, D, not BC. Right click. Now we could just, like I said, we could just bake this out with a cache. I've run into problems with that, so let's just bake it out as a lembic. The main problem I said is if you bake the dynamics and then you put in the subdivision surface, it'll play through for a while and then it'll suddenly turn itself off, and I have no idea why. Now it's just going to take a little bit to calculate. There's a lot going on. We have a decent poly count, but once it's done, we'll be able to see it in pretty much real time and turn the subdivision on, which is what we really want to see here. But the idea of like we can make more than one spring and pull from more than one point, and those 2 points, the springs could pull in 2 kind of different directions, or it could pull on opposite sides. It could pull it, like artistically, we could pull it from one corner and drag it off the letter. Like if it was up here and it pulled across the floor that way, actually it'd be kind of cool test to do next. Drag across the floor that way, then it's just going to go, it's going to get pulled up the side and then across it and then down. That'd be neat. Another one would be to grab it on this side and lift it, kind of maybe a diagonal, or like grab it here and pull both up, like maybe right there and pull both up. And then it would kind of get reveal. Well, it's just a bunch of different ways you could reveal it. So there ends up being a lot of artistic freedom in the way you want to pull that off. And this this particular method of letting it drop, grow the fabric, bake it, and then run it on it again is pretty. It's a pretty elegant workflow. It's not bad. Let's see, what else can I talk about? We lost 17%. Yeah, those can get pulled. I mean, you could even do, I don't know, you could put as many points on here as you want and pull them up. You grab 4 corners and pull straight up. That would be a little more boring, I think. I saw earlier somebody was asking about, Richie was asking if we could pull a cloth from a table with objects on top of it without them falling over. I think you could. Why don't we use cloth? We don't use cloth because cloth cannot handle intersections. Even though there's like a setting for self-intersections, it gets insane once any piece of cloth touches itself. It doesn't know how to handle it. So yeah, we immediately go to soft body. It's just better simulations across the board. That's why I'm not using it. And I know there's XP cloth, but even that, I'm not sure exactly what it's capable of. So I just was fairly confident that if we could get this to start working in soft body, that would be the best way to do it. There's a couple settings I really wish that we could take from cloth and put in the soft body. That'd be so amazing. Okay, this is done alembicing. So let's be very careful. I don't want this to simulate, so I'm going to pull that out. We're at the time of 0. Pull the dynamics tag off, so now no simulation is happening. We can turn it off, but that's like clean workflow as well. We've got our alembic. Turn on subdivisions here. Oh, hide the cloth. I was like, what? Why doesn't it look good? Okay, there we go. Looking a little bit better. Let's see. Hit play. Oh my God, it's beautiful. Oh, it does explode at the end, so we need a few more steps per frame. But look at this. Ta-da! It feels like it's getting pulled off. That is brilliant. I really like it. Wow, I didn't think we'd be able to get this nice of a cloth simulation out of cinema. To tell you the truth, like look at these wrinkles. Like that's a baked down wrinkle, and look how like it's pulled and stretched and straightens itself out. Like that's gorgeous. Wow, look at that. I am impressed. Good job, cinema. And I mean, and this is not even, there's a lot of things that we haven't even tinkered with, like a lot of additional layers. Like you could just put a turbulence in. We could make a turbulence so there's a little bit of extra wind and wiggle if you wanted to. And we didn't even do something like that. So that's looking great. I love it. I will save the scene file, although alembic files might be a little bit bigger. Alembic. Might delete that one if it's huge. But that was great. Let's delete that. Let's put our cloth back in, unhide it, make it a simulation again. And now let's try pulling the cloth straight off of it. I like the setup that we have, so I'll do a very similar thing. In fact, I'm just going to make a copy of our spline path. Call it spline path 2. Select all, shrink. I guess I'll just delete those two. And then select both of those, say hard interpolation, grab this, move it over to here. So it's visually about the same length. I don't think we need anywhere near the same length, but pull the starting point over here. And that's just going to, the hope here is we'll just pull it across the floor. I'm just eyeballing it. I don't think we need to be overly precise. Cool. So that is the start point. So now the spring should look at path 2. It's going to jump over there. And the point we want it to look at is... Nope, too far. There you go. Something right around here. Right there. Good enough. Ink, ink. There. So it's pulling somewhere near the top. It's going to start right away. Same exact simulation. Everything else is the same. It will take a little bit longer, but I'm going to give us 2 more steps per frame. Not too much, but, you know, it's something. Just to let that calculate more. We'll do a little bit more of a top view here. And I guess we can... we're going to bake to alembic, but let's just play through a few frames and see if it seems to be working. I did forget. It's not a big deal, but I did forget to go to the spring and say set length. Very important for making sure the first frame doesn't suddenly twitch. Um, Okay, so you see it doesn't twitch in the beginning. A little bit of that settling, but that should start traveling. Why is it not moving? Spring, position, travel over the course of this. Yes, good. Oh, yeah, that was also moving, wasn't it? Go away. It's in the proper spot. 100. Where does it go to? Next keyframe. 100. Oh, it goes to frame 100. Oh, interesting. Seems strange to me. Play. Why isn't that moving? All right, one moment. Path 2, yes, good. Spring, yes, good. Position, yes, 0. Don't need tangential traveling along that path. Dynamics, turn off. Run. Spring. Okay, yes. Why is it? I thought we made that linear. It's not linear. Maybe we undid it. It was ramping into it so slowly that I wasn't visually seeing it, so that was the problem there. Apologies. Okay, back to here. Move the dynamics back on. Nothing else should change. It's still connected. It's all good. Careful. Rewind to the time of 0 and then move the dynamics tag on there. That's connecting approximately the right spot. I'm not sure if something changed. I'm just going to set rest length. Okay, that is cool. There, go. Hit play. It should start moving right away this time. Yes, it is. Immediately, this cloth is tugging. It's a good thing. Let's see. Nice so far. Tugging this taut. The wrinkles on the top are getting cleaned up as it doesn't have enough fabric to work with. Oh, that looks good already. Now, there is still friction on the floor. I don't know that that's a bad thing. We might want to turn it off, but I don't know. Maybe we do. Maybe we don't. Maybe a little friction on the object is good, but it would be fighting with the stretching. And that we might want to not have it be fighting the stretching. Going well so far. It's almost abstracted the shape even more. We're getting less information on the shape. I feel like the spheres we have around the edge are doing a really good job of keeping the shape, because normally I feel like this would be passing through the text a lot, and it's almost not at all, which is pretty impressive in itself. All right, we're getting to the last of it where this is actually pulling up. Oh, that looks good. I wish we had baked it. I just wanted to make sure it was looking good. We should have stopped it right away, but now I don't want to stop. I'll start the alembic and then talk to the chat as soon as we get a little bit more of the reveal here. Just make sure it doesn't break here at the end. Oh boy. It'd be great to do this kind of thing and then have the text underneath like be something different. Like it pops out and, it's like a troll face or something ridiculous. Because this is quite obviously what it is, which is kind of fun. Yeah, that was working pretty well. I'm going to pause it. It's clearing it pretty quick, so I think we can drop this back to about 80 frames. I just got to remember that the spline's getting cut off at that point. That's all getting tugged straight. That's fine. Just as an experiment, I'm going to increase our drag. Force drag, I'll jump that up to 55. No lift. I kind of want to, this is I guess we're already at double gravity, but if the gravity's really strong, it's going to be like really taking on the contour of the shape really accurately. So I kind of want to push that further. I don't know if it's a good idea, but I'll double it again. Why not? Just to have it be fun and see if it keeps the shape a little bit sharper. And I wonder if, like, I mean, it goes back to, like, we're dropping our damping down to 0. I wonder if a little bit of damping goes a long way, or if we don't need any, or if increasing the shear and flexion will maintain the wrinkles a little bit more. My assumption actually would be that it would maintain them better. Could be really ugly, but hey, why not? Let's jump this up to 5%, 5% on the damping, and 50% on the shear and the flexion, which should really kind of maintain the wrinkles a little. And we'll see if those can be maintained as they're pulled. It might not look as nice, but hey, it'll give us new information. So that's all working well, which means I can save it and bake as Alembic and take a look at the chat again. Yep, very happy with that. I know we're going extra long here, almost an hour, but we're getting good information here, and I almost feel like I'm at the point where it's like, okay, I could just sit down and immediately record a tutorial. Jake, yes, also exceeded my expectations. And now that we're actually getting it working and we've actually got a workflow that's reasonable, and we're understanding how and why it's working, that goes a long way. Be having a, like, thanks, man. Yeah, we just keep on trying again and again, and slowly we get the proper effect going. And it's always impressive that you can push the cinema systems. I mean, this soft body simulation has been in cinema for so long, and I've never pushed it this far for this type of task before, so it's pretty cool. Thanks, Blue Tones. You've been on the spot. Or spot on, that's the right phrase. You've been spot on with the little mistakes I've been making. It happens all the time. I'll be watching a tutorial. I'll be watching someone's tutorial on something, and it's like I see them make a mistake, and you're just like, oh, no, they made a mistake, and they don't know, and they don't, because of the way they're working on it, they don't realize it for 20 minutes, and now it's so far in the past that they're not going to know what it is. You're like, ah. But, of course, they recorded it like 6 months ago, and you're like, oh, like, I feel your pain in the past. We were, so you're the one who asked the similar question a year ago. Like I even said yesterday during the stream, it's like, well, we get these kind of questions a couple times a year, but let's try it again and see if we can do a better job. So, yep, you trying it again and again, even when it doesn't work. Honestly, that's like the history of me learning Cinema 4D. When I tried learning rigging, it was like I tried and it just failed horribly, like rigging a full character. And I tried again, and I failed horribly. And I tried a third time, and one thing sort of worked. It's like, well, okay, I kind of get it. And it's like the 6th time, it's like, okay, now I get it. Now it's working. Now I can apply the principles and what I've learned all over the place and make it behave exactly the way I want it to. So merely trying to do it again and again and again. There's something to it. I know when people are on the job, it's going to be really difficult to just do testing again and again and again, but that's how I learn everything, is just pure repetition. Okay, let's do the setup again cleanly. Pull that out. Not dynamic. Yes, Alembic. Turn on cloth surface. Hide our geometry. And hit play. Oh, that's beautiful. Oh, it cuts off a couple frames too early, but you can see by leaving in the shear and the flexion, you see how this cloth isn't perfectly straightening itself out anymore. It's kind of maintaining those wrinkles a little bit. That's what that gave us. Got a little bit of geometry peeking through here. I mean, there's a lot of ways you could get around that. First of all, we could just hide the original model. This model could be completely hidden until right here on this frame. So on this frame, you suddenly turn on the model. I mean, I guess it's still peeking through there a little bit, but then nothing before that point matters. All those little intersections make no difference whatsoever. But of course, a couple little spheres on those problem corners would go a long way. Oh, it's so clean. That is great. I'm going to give us 10 more frames. And let's change a couple of settings. Thank you, Alembic. Don't need you right now, though. Make it dynamic again at the time of 0. Unhide it. I like the damping and the shear. I'm going to drop that to half the amount on the two of them. The structural, I want it to have a lot of structure. I don't want them to be able to stretch. So I don't think it's stretching that much, but you know what? I'm going to go up to 300. And then I am going to go to the floor and get rid of all of its friction. And yeah, what else would I want to change from what we just saw? It looked really good. It was already dynamic. We could, just because it's not taking that long, I can grab our two little sphere outliners that were there, and I'm just going to cut that in half, which I think we did before in a different file, but not here. So now there's twice the resolution of little spheres that should be protecting it. So this first frame obviously will be broken, but everything after that will be smoother. And yeah, there we go. That's that. And we'll do one last alembic bake, and then I think we'll be done with the stream at a full 3 hours today, which I'm not complaining. It's been a lot of fun stuff here. Turn off subdivision surface. Oh, that's weird. Why is turning off subdivision surface making everything disappear? I'll just pull it out because that's weird and scary. Yeah, maybe this should never be done inside of subdivision surface because that does not like dynamic, so it should not be in there. But it all seems fine. Nothing else changed. Let me hit save, go a few frames in just to make sure. Yes, all seems to be working. And right click, bake as alembic. All right, we'll let this bake go through, check it out, and then wrap this one up. Man, we've only done 2 episodes of Rocket Lasso Live Season 2, and it has been really amazing questions. I've been so happy with the quality of questions and us trying to break through and all the new features in cinema. We haven't even gotten to play too much with field forces. We played with them a little bit here, but it turned out that they weren't even super necessary. Like, there are things we can do. Like right now I'm just cranking up the gravity, but you could imagine building a rig instead where it's like pushing down in all the places where the text is not. Things like that to keep it smoother along those lines. Create a little bit of wind or extra drag on different parts. There's definitely a lot of possibilities here, but I don't think any of those are super necessary. And honestly, we're running this entire thing at a lower poly count than we were yesterday. And even with that lower poly count, I feel like we got a better formula for good wrinkles. So that pushes it even further. And it's funny, like I suddenly remembered, because I used to work in like production where, you know, it's the kind of thing where it's like a lot of drapery, a lot of cloths, a lot of things like that. And I suddenly remembered, I don't know from where, but it's like, oh wait, whenever you're covering that kind of thing, it's not a square cloth, it's usually a round cloth. And it's amazing how much of a difference that made because of how pointy it would get and the way all of those things lined up. Let's see. Oh yeah, Jake. Yeah, being able to make mistakes and not freaking out about mistakes is the best way to learn. If you're always worried about I can't fail, then there's a lot less exploration. Level bevel. Yep, it has been a very, very good 2020 so far. 2020, it's finally the future. We're in the 20s. It finally isn't the year 2000. It felt like the year 2000 for way too long. I think mostly because, like, you know, the aughts, the first like 10 years of 2000, it's just like the aughts. That doesn't feel like anything. And then the teens, like, that's not anything. But now we're in 2020. It's like, okay, now it's 2020. It probably won't, 2022, 2021. Yeah, that feels like time would be progressing. I don't know. It's a weird concept. Andrew, yeah, thanks for coming and hanging out. I love having some people to, like, even this one. This has actually been a really good example. It's tricky because if you were here for episode 1 of, from 2 weeks ago, a lot of people were trying to give me suggestions for the optical illusion, and I knew there's a lot of obvious things, and I knew that all the obvious things were wrong. And everybody's giving all these suggestions. And it's like, okay, those are my first instinct, but I know that's not it. So I have to ignore the chat. Even though I desperately want to listen to what everyone's saying, I have to be like, no, I'm not going to do that. And now this one is a case where there's been several suggestions from people in the chat that I'm like, I am just completely lost. And it's like, what about this? It's like, oh my God, that's exactly what it is. So okay, let's just check out our final simulation here. And let's keep an eye out on the little white spots as well to see if they do clean themselves up. better than last time. Oh, it's so good. Look at that. I'm surprised the wrinkles are still maintaining themselves as well as they are. It could be the damping goes a really, really long way. So, you know, I would want to do a couple A/B tests for like killing off those wrinkles. Yeah, okay, these corners still need maybe a little bit of love to not go. But although I do want to say, look right here. Oh, I guess maybe that's a problem. I don't know what exactly it is, but I really love this pinch here. We don't want to see that white, obviously. So if it's a problem, if this is actually an error of it passing through the geometry, that sucks. But I really love that little pinchy flow happening right there. It's keeping that definition going for longer. And then because of the extra gravity, you can still see this implied shape here. You can still see this dark patch implying the shape of the letter underneath it. But like I said, all of this text poking through is not that big of a deal because you always hide the text until the absolute last frame. Like in this case, like, oh my goodness, like here, like we still, I don't think would, maybe right there. Okay, well, I guess maybe a couple of the frames here. But like we don't need to turn the text on until like frame 60 where it finally is going to get revealed. And even along those lines, we haven't and probably very well easily could put this into a cloth surface. Oh, maybe not. Let's see, no subdivision. That's interesting. What is I just had to zero out the PSR, but I don't know why I didn't like that. But in any case, increase the thickness here. Oh, there we go. Just by doing 2 levels of thickness on a cloth surface, but we could probably push that even further. 2 levels of thickness. Going to give it that little bit of thickness. There still might be a couple little peek throughs here, but adding in that thickness is going to pinch it all up, and actually it almost completely cleaned up except for that little dot in the sharp corner. So boom, that goes a long way to fixing that as well. And just look at how good that looks. Actually, I'm curious what this cloth looks like as it gets stretched out. We did, I mean, it's just a different simulation in general, but the it's actually kind of boring once it gets pulled away from the interesting shape. Not surprising. Makes perfect sense. And then, of course, you can drag it backwards. Glom. There's a lot of fun to be had with this. I am looking forward to this full-on proper tutorial. Let's see. Yeah, well, I'd say, yeah, level. I mean, I agree. It would be pretty cool to put some different textures on here. But for making a tutorial, like just making this simple gradient velvet is so clean and so simple. I think we could probably just even go in here and make a very quick bump. So I can make a bump material. This does show up in the viewport, right? Yeah, so there's a bump. If we make this really tiny, or is there a limit on what it's going to do? 0.1? Oh, it does seem to like go to it can only go to a certain resolution. Editor, default. Oh, interesting. So we have to increase the texture size here. But as I increase that, it's going to increase the detail of that bump. And that's a little strong, but if we do just a little bit, you can just get that little bit of bump texture coming through. And I think that looks amazing for a viewport. I don't know for sure, but I think that material cranking the material preview size up is causing cinema to slow down a lot. Let me go back and see if that's actually the case. No, I guess just the alembic is, or is it just the bump in general? Bump, clear. Yeah, just turning on the bump kills the keyframe significantly. Interesting. But anyway, my point being is for in viewport viewing, like it makes such nice looking velvet just in the viewport. No complaints there. Okay, that was a lot of fun. It was a little frustrating in the middle, but it's like, no, we're going to plow through. Thanks everybody for the help. It was incredible. I guess it's important to note that, once again, especially this bonus stream is made strictly for people supporting on Patreon. I wouldn't do it otherwise. So without Patreon, this particular stream would not exist. And the hope here is to elaborate on things we learn and then be able to turn them into full real tutorials. That's the goal. So I'm going to wrap this one up and run the credits for everybody who's supported so far. So thank you so much, everybody. I'll see you on Slack. If you're not already on it, make sure you go to rocketlassoslack.com to get a sign-in. And otherwise, I will see you on Wednesday for the next proper stream. So thanks, everybody, and goodbye.